Nobody listens to me, but I'm used to that. And that doesn't work either. Wo macht man's an? Yeah, yeah. Okay, I guess we're gonna get started. Can you hold everybody here?
Should I use this one or that?
I think this is more convenient. Kannst du mir mal kurz helfen mit dem?
Yeah.
We are just as on time as the German train system today.
Yeah. Thanks.
Which means always late. Anyway, every day a bit more late, so it's just exactly like our train system and the rest of the country. So here comes German punctuality. We are going down the train here. Anyway, I'm glad to introduce Daniel Casagrande, who is with us from Chile. And while they always say, well, they are not a real partner, due to all the activities we had together already, they are already a real partner. And we consider them partner, and we kind of see what we can do about it. So I'm sure we are writing more proposals where O'Higgins is going to be part of it, or see how we can widen the network also officially with the DAD. Daniel, I'm going to tell you a little bit about his CV. Has received a degree in electrical engineering at the University of St. Louis in Argentina, followed by a master in mechatronic systems engineering that he did at the Hochschule Karlsruhe, not KIT this time, but Hochschule Karlsruhe.
Yeah.
And you speak German, I'm sure?
Ein bisschen.
Ein bisschen, good. Anyway, and partially, obviously, at the University of Oviedo, Spain.
Exactly.
So it was a master in conjunto? Or
Yes,
so
a joint master degree.
A double degree or a joint
Exactly.
degree. Interesting. And afterwards he pursued a PhD in Italy at the University of Udine, for us, Udine anyway. So he's very international. Yeah, by now he's probably got the European citizenship or something like that, on top of the Chilean. And his main interest areas is vibration control, design and control of mechatronic systems, as well as digital fabrication and education. So, I mean, the perfect person to say it. And he will talk about Fábrica Digital at O'Higgins University.
Okay, great.
Thank you, Waltraud. I'm very happy to be here, and I'm expecting to make connections with people here. I think we have very interesting common interests. So I wanted to present first the Fábrica Digital O'Higgins. We call it, it's a fab lab. We call it Digital Factory O'Higgins. O'Higgins is the name of the university also where I come from with Rodrigo, and the name of the region. And well, I'm the manager also of this fab lab. So for the people that weren't yesterday at the fab lab, what is this Fábrica Digital or the fab lab? It's the first one in our region, and it is, I'm going to be very quick in these first slides because we already started a bit late, but this is an open space where people can learn about new technologies and create prototypes using digital fabrication. And digital fabrication is this, when it's not new, it's a relatively new paradigm of making things in which we have a design, a computer, thanks, Rolf. So we have a design in our computer and we can send it to a machine and we can build something, right? So traditionally there is a user or a man that takes a tool and create an object. And in here we can just design our product, send it to a specific machine, and then we can do things like this, which is well, we can make these cuts and make this part flexible, right? This is a wood part. We can do a lot of different things, and we can combine also all these pieces to create functional prototypes. In our Fab Lab, well, 3D printers are maybe the most popular machines now, but there are many other different technologies. We have around 15 of different 3D printers. We have these laser cutters for different materials also, CNC milling machines for different materials also, including metal. We have also this 3D scanner, which allows us to, instead of designing something, we can just put it here, and this turns, and the 3D scanner just captures the shape of the object. So then we can modify it, print it again, and so on. And in our Fab Lab, we also have this, we call it induction courses or trainings, in which people can come, and in between 1 hour and 2 hours, they learn the basic skills to use one of these machines. So the idea is that they have to produce something. It's not theoretical. It's limited to around 8 people because they have to do it. It's a hands-on training. And we do it for the laser cutter, 3D printers, for the milling machine. We have this. So this is an example of all the people here doing the 3D printer induction training. And after this, it's a short theoretical, let's say, lesson, and then they have to print a part. And we do it also for Arduino, for designing in 2 and 3 dimensions, 3D printing, and for the laser cutter. So we opened the Fab Lab like 1.5 years ago, and in this time we have given, or people have taken 650 spots in these induction trainings. We also make like a one-time training courses, for example, for Autodesk Inventor, or for design thinking and other softwares. We also give these free lectures, and we also get a lot of visits from schools and entrepreneurs that are looking for prototyping certain parts of their business. So this is some of the numbers of our Fab Lab. And I wanted to show you also some of the projects students have made. I've not been involved in all of these, but we are working, for example, in this one, participating in that one is just to create this for gym rats. This is like a gym, so they can come here, and to eat they have to do certain exercises. This one, there is also one to run, like I don't know how you call it, this running machine, but it's the idea is to make these kind of things that are also friendly for these gym rats. All of these, of course, are doing using digital fabrication. There are researchers working on fluid dynamics and other things. And I want to present now 2 of the projects that I'm, well, this one I'm doing it with a colleague in agriculture, and the idea here is to create this relatively low-cost root phenotyping platform. And for this, I wanted to give a brief introduction or a context about the motivation of this project, and this has to do mainly with climate change. You know, I think that most of you already know that the scientific consensus indicates that the climate change is due to human activities, mainly driven by greenhouse gas emissions, in which carbon dioxide is the main cause from burning fossil fuels. And if we look at the right part here, which is the emissions of each country, well, China is leading with almost 1/3, the United States with 15%, the European Union 10%, and so on. And if we look at here, Chile is not even here in this table, right? So Chile doesn't produce a lot of carbon dioxide, but it is highly susceptible. So the UN says Chile holds 7 of the 9 criteria used to define the susceptibility of the country. And well, here are these 7. So Chile is this very thin and long country. It has a lot of coastal area here on the west, and it has a low altitude in these areas. And well, these are all 7, and I'm going to focus on this one, areas prone to desertification and drought. Chile has been now for 10 years in a drought. The UN call it a mega drought. And just to give you an idea, in Santiago and in Rancagua, in the region where we are, usually there were like around 350 millimeters a year of rain. And now in the last few years, it's been around 100, 150. So it's actually quite dry. But this region is also one of the main producers in fruit production, right? So water is a really important topic and very relevant now to use it wisely. So coming back to this project, this root phenotyping project, why are roots so important? Well, in this context of low availability of water, plants can adapt, right? And usually what we see when plants adapt to climate change mostly is in the canopy. And the plant can adapt its shape and also its functions. But when we are dealing with low availability of water, then roots are the main organ that adapts. So, well, my colleague studies roots, and studying the morphology or certain traits of the roots, he can establish which varieties or which plants adapt better to this condition, right? Low availability of water. And, well, roots are important because they provide anchoring to the ground, they absorb water and nutrients, they also store food, and they are useful for plant propagation. And this would be what we wanted to do. This is an example of a pipeline for root phenotyping. So we have our crops, we have to extract the plant, clean the roots. With the roots, we cut it here, the stem, and we only have the root. And we make a lot of pictures, of images. There are different technologies here. We are using only RGB, let's say, normal pictures. We make a model of this root, and then we calculate certain traits like stem diameter, root length, and so on. And with this, the idea is to identify and choose the plant varieties that adapt better for, in this case, low availability of water. These are 2 examples of phenotyping pipelines. This one on the left is for chickpea, and they do it on the canopy, right? So they take a lot of images around the chickpea canopy, and they also make something similar. So they make the model, and then they calculate certain traits. And in this one, which is the one that we took as a model, they do it for maize. So they have these maize plants, they build this platform to take the pictures. With the pictures, they make, they reconstruct a 3D model, and then with the model, they can calculate certain traits like the stem diameter, root length, the volume of the root, and so on. So in our case, We have this prototype now where we can fix our route. So we use this stand and we fix our route here. And this whole structure rotates around the route. And we have some normal USB industrial cameras here, but these are relatively low-cost cameras that takes images of the picture while rotating, right? So we can take like one picture or more at each degree. And we can make this kind of data set. So this is a video, but actually it's 500 photos just put together. Right? So we can have these data sets, and with these data sets, we can construct or reconstruct the 3D model of the route. I did this just before coming here, so I didn't have time to process this one. But the idea is to do this, right? This is a relatively simple route. This model here, so this is a picture, and this is the 3D cloud points with only 30 images, right? So this takes time to process. The other one with 500 images, I tried to run it here in my PC here, but it wasn't going on. So the idea is to do this, and then to measure certain traits here, like root length, the stem diameter, and so on. So this is where we are now, and we are testing our prototype with, let's say, real roots. The root that you saw before, it was just a test to see how it worked. But now my colleague is, he has this trial with watermelon plants, and he's extracting the roots, and we are creating this data set. So the idea is also to build these open access data sets. And we are also working on our algorithm to calculate this particular trait. This is one of the projects I wanted to mention. And the other one is this regarding digital beehives. I saw that some people here is also working on this. So what is the motivation for this work is that there is a decrease of the bee population. This is happening worldwide, and the reasons are not so clear, but there is consensus that it's due to climate change, air pollution, urbanization, and the use of agrochemicals. And why is it so important to understand what is happening? Well, 70% of our food depends on pollination, right? On bees going from one flower to other. It is important for honey production, but in our region, in Chile also, it is very important for fruit production, right? Our region is the region that exports, that has the higher exports in fruit in Chile, and in many fruits it's one of the biggest producers, Chile. And if we see here in this image, we can see how much each of these fruit or harvest depends on pollination. So for cherry fruit it's 90%, for blueberries 100, avocado, almond also 100, kiwi 90%, and plum 70. So it's very, very important for the production to have a good pollination. This is how beekeepers traditionally assess the beehive condition. So they have to do an outside or exterior inspection. They check on the behavior of the bees, how many dead bees are around the beehive. They also can check the weight, the sound, and smell of the beehive. And they also have to check inside, so they have to open it, which is not so good. When you open the bee, you are also cracking these seals that the bees make with propolia. And they check the condition of the queen, the eggs, the larvae, and also the wax, honey, and pollen. So each time you open the bee, you also are stressing. You open the beehive, you stress the bees. And the idea of these smart or digital beehives is to equip the beehives with sensors. So we can sense certain parameters. The idea also is to be able to monitor these beehives at a distance, so you should upload the data to the cloud. And like this, you can reduce the times that you have to go to the beehive, open it, and check this in situ. These are examples of already, well, this one is more a scientific beehive, this one is more a commercial one. But the idea is to help beekeepers to keep their bees safe. And we wanted to do something like this architecture, so where we have our nodes here, which are installed in each beehive. We transmit the data via a LoRa network to a gateway and then to the cloud. In this project, we are here, so we already built this beehive. This is a Colorado top bar beehive, so it's different than the traditional boxes. We did this one because it's more appealing also. So it's nice to see. It's also easy to assemble and transport. We wanted this to be like a demo, right? So we can take it and beekeepers can see it and see how it works. This was developed by the Fab Lab Barcelona and this Open Tech Collaborative Institute in Colorado. We equip this beehive with load cells, so we can weight the beehive. And we have here a connection box where the processor is. We also have a GPS and the LoRa antenna. And inside the beehive, we equipped it with these two sensors, with a microphone and the temperature and humidity sensor. So what can we measure? We can measure temperature, humidity, we can measure the weight and the location of the beehive. And we use the microphone to detect the peak frequency of the signals inside the beehive. Some researchers proved that certain peak frequencies are related to specific events in the beehive, such as when the bees leave the hive, when there is some external other insects that attack the beehive. So all this can be related to particular peak frequencies. So it's an interesting feature to measure. We transmit the data to the Things network via LoRa. We also have it solar powered, but that's a question mark, because the things we have done it just in the lab. So the next steps are to test this in the field. We have to tailor down these electronics that it's standard, low-cost electronics to a particular solution, so we can reduce the power consumption, and then we have to assess if it's solar powered or not. And we're going to have beehives in our campus in San Fernando, and we want to test it also with finally with beekeepers, right? And once we are there, the idea is to produce high amounts of data and analyze, and we will see what we can do with this data. And to finish, I also wanted to show you these two other projects that I think that are related here to what you are doing here. One of them, both of these projects are starting this year. They are 3-year projects. FIC means that it's a regional fund. The first one is a climatic chamber. It's like a greenhouse, but you can set up certain conditions to simulate, for example, the conditions that the crops in Chile are going to have in 10 years, right? So we can go up in temperature, go lower, and this will help us understand how the climate change will affect the local crops in Chile, in that region, and it will help us develop these adaptation strategies for the local crops. The idea is to develop varieties of these crops that can adapt better to the local conditions, and we also want to develop and promote the use of low-cost sensors for agriculture. And the other project is related to digital fabrication. We want to continue promoting the use of these technologies among young students and teachers. The idea is to install these kits of digital fabrications in schools, at least 15 schools. We have to decide which kind of machines we're going to install. We have already done we have some experiences with 3D printers, which went really well, but we also want to do some other things with Arduino, maybe other technologies also. And there is a big gender gap that we want to tackle also in the use of these technologies. And the last one is also to promote entrepreneurship through the use of these technologies to create prototypes and validate business. So this is it from my part. I thank you for your attention. I listen to any questions you may have. Carlos. Yeah. Yes, there are different traits that you can measure. So one is the length, the stem diameter here. You can also measure the angle here of some of these roots, and total length, so that means the length of all of these. Yeah. Yeah. Yes, I'm well, the expert on exactly which traits are correlated to each parameters that we are seeking is my colleague that he's an agricultural bioinformatics. In my case, I'm more I'm working on the technical part of calculating, creating the platform, and then calculating the traits that he defines that are useful for each trial. But thanks. Yes. Mm-hmm. The growth rate. Mm-hmm.
Well, they are reflective, so that might be a possibility to measure the amount of root hairs. So you can, their optical properties are different than the main root. So that might help you detect the number of root hairs.
Of root hairs. Yes. Sorry? Yes. The idea. So you have to do, it's a destructive test, right? You kill the plant when you do it. You have the plants in the soil. The idea is to have the same conditions, not to make them grow in pots, rather where they're going to be, right? And then you have to extract it, so you have to take a big amount of dirt out just to prevent from damaging the root. You take the soil, you clean it with water, dry it, and then you have something like this. So it's destructive, you just do it once and that's it. You have other technologies where you can do this, for example, with plants in pots, and you can do like, I don't remember the name of this machine, but it's like the one that we use to see if we have a bone, something wrong, right? Yes, exactly, X-ray, but it's very expensive. So you can do it there, and there it's not a destructive test like this one. Yes. Exactly. I would say that these are like two alternative approaches, because my colleague is doing that actually now. But the thing is that when you use the rhizotrons, so the plant is growing just in a plane, right? Because you have the two walls very thin, and so you can see the roots. But then you get something just in one plane. I don't know actually, I haven't seen that. I would say that these are alternative techniques, and the idea here is that you can have measured this volume instead of estimating it. Yes, Imran. Yes. Yes, we have, but that's, I put it like in a question mark just because of that. So now we have it, we have a solar panel, we have a battery also, but we have to see if that is feasible to do it with all the beehives. We have to see when we tailor down, because we are using like standard, very cheap sensors for this, and also an Arduino Mega, which is so we have to see how much energy we can save, and then assess if it's possible to do it solar powered, if it makes sense. So right now we have it, but it's with this first prototype. Yes, Rolf. Exactly. That's very interesting, actually. Because you have to calculate this fast Fourier transform, and we do it on the Arduino.
You could use other devices as well, right? So you're using this X-Mega, you said?
Yes.
Okay, we are using currently ESP32.
Mm-hmm.
They're much more powerful, they're low power, they have Wi-Fi included.
Yes.
And so we will present hopefully tomorrow, right? A few more on LoRa. So we are quite happy with that.
Good.
So I think that Arduino is not the...
Yes, it's not the right...
And the other question I have is concerning the roots. So you are using photogrammetric software, structure from motion.
Mm-hmm.
Are you use Agisoft, or are you using kind of open visual SFM or something?
We are testing actually these two algorithms, the ones that I presented, these two pipelines. So this one is you can, well, you see the software they use, exactly. And in this case, they made their own software, and we are testing that one also. This, so they have like two software that you can download on GitHub. The first one is to reconstruct the, exactly, and yes. This one, so this is a very complex route, the one from the mice. You have different, these walls. So this is a very complex route to analyze. In our case, we are dealing with simpler routes, so we are just adapting this one, and we're also trying what they did here.
Was a master's thesis in my team. This guy extracted, so he has a tree segmentation algorithm from laser scans. It's a similar problem.
Mm-hmm.
So a lot of points.
Yeah.
As a human, you see there, this is supposed to be a tree, but how to extract this, right? He has a very, very simple algorithm, and it was very efficient. So maybe they can.
Yes. Great. Thanks. Yes, Eric. Yes, good. That's also a nice question. So that's why we don't have so many sensors inside the beehive, and we haven't tested yet, right? So this is in the lab, but so we are putting the sensors inside this bag, right? So the idea is that bees cannot access. Yes. Exactly. Yeah. But it's just a simple idea. But anyway, so we have to test it.
There is even a sensor measuring the electric properties of what is the breed. So where you can really see whether there is a varroa infection or not. So there's a lot of new sensors developed in this region, I would say.
Peak frequency corresponds to the problem.
To some,
Depending on the problem, you get a particular frequency. That's what I'm curious about. Because,
yes, I mean it's not any problem, but there are certain frequencies that, for example, for some issues, the bees start to be more nervous, so there's more activity. If there is more activity, then the frequency changes. And I mean, maybe you don't know exactly what the problem is, but exactly, you can get an alarm and then you go and check before it's too late, because otherwise the beekeeper goes today, maybe it goes next week, and then
that's clear, but I was wondering how fine-tuned it is, right? Whether you can really see, okay, the bees are taking off now because it's getting too dense and so forth. So I think that's feasible
Mhm.
to be able to detect this. But if there's an invader, of course they will respond differently than if the swarm decides to find a new location. And I guess that would also be feasible to find out. But of course, then more fine-tuned, I think it's going to be a problem.
yes. Mhm.
Are there more questions?
Yes.
It's not that you have to have the answer right away, but in one of your objectives, you mentioned to tackle the gender gap in the use of the technologies.
Yes.
You identify the problem why this gender gap occurs.
Good.
If you have the answer, it's okay.
No, I mean, I can answer maybe partially. So our region, we are focused on dealing with this in our region, right? In Chile, in that particular region. And for example, in the university, almost, I would say like between 80 and 90% of the students are the first member of the family that goes to the university. So this is a profile that's very different from other regions, from other cities, right? And I would say it has to do with this cultural environment in which women are usually not promoted to study I mean, we can see it in the lectures where someone has to code something, and they are working in teams, and none of the girls want to do it because they say that no, I'm not so good, and then male students do it. So we have this kind of situations. I think it's in general it's like this. I think it's more pronounced in our region, and the idea would be to try to change this. So we have a lot of girls going to the Fab Lab, which I find it great. But inside, I mean, within this new project, we want to make more activities starting at a young age also, because the literature says that this gender gaps starts around 8 to 12 years old.
We're facing the same problem here as well. But we are also trying to find solutions. That's something that we discuss about.
Good. We have well, I didn't present the team, but we are 4 researchers, and we have 2 people working full-time in the Fab Lab, which is also a challenge to to sustain. You're welcome. Good. I think that's it.
Anyway, I guess there's lots of things that are very interesting to us, especially since we are doing a similar project here also. But I think that's the way it goes. I mean, with the climate change and so forth, new problems arise, and especially when it comes to crop production. And so we can learn from each other, and I would have been happy to bring you to Jülich and do similar experiments with roots and so forth, but we may be able to make the connection between you and Jülich and so forth. They have very good equipment towards this, and also do a lot of photosynthesis measurements, but also root measurements, and also concerning climate change and so forth. So those would be also interesting partners for you.
Yes, for sure.
Thank you very much for your presentation.
Thank you.
I guess we move on, and now normally it would have been Dietrich Dahl's turn. Unfortunately fell sick. Oh. And
It's on already. It's on.
now it's off. Okay. I do not know for sure who is taking over the talk of Dietrich Dahl. Okay. Sorry for that, but Dietrich was supposed to be the showmaster today. So you are now for yourself, the showmaster for yourself and for Dietrich.
No, I will not play showmaster. Sorry for that. But I will.
Well, I can make a few handstands while you.
Good. We can discuss later. But no, I will present Professor Dar presentation. Can you hold this, please? Can I install the laptop quickly? Yes. Okay. Let's have a look how this works. Good. Okay, thank you very much for having me. My name is Itse Jelsma. I will be replacing, I will be giving this presentation for Professor Dar, who is unfortunately ill today. Um, so yeah, I've been given this presentation yesterday, so apologies that I might not know all the details. My friend already, or my colleague already called it PowerPoint karaoke. Let's see how it goes. I'll do my best. So what it's about big data applications to monitor forest state and global deforestation. Yes, of course we see that deforestation is still quite large. It's still happening quite a lot, but we see big differences throughout the world. In the tropical countries, the humid tropics, we see most deforestation there in Brazil, Latin America mostly, Africa and Southeast Asia mostly. But luckily we also have positive trends, and we see quite some afforestation or reforestation in China. We see the forestry, the canopy cover increasing in India, which are important, of course, and there in the United States, and slightly in Western Europe. But deforestation clearly is not a problem just in the tropical countries. We also see a big problem of deforestation in Western Europe. This picture is taken, I think, by Professor Dar in the Harz. I think he's originally from that area, close to the Harz. It's a hilly area in, near former Eastern Germany. And we see here that Käfers, how do you call them? Beetles. Beetles have attacked the forest, and we see quite some deforestation happening because of pest and disease increasing due to climate change. We see, climate change is happening. The original native species are exposed to a different climate. There is less, they're less resistant to that, to these climatic changes. Induces stresses to those trees, and they become more vulnerable to pests and diseases. There are great big data tools out there already. Global Forest Watch is having real-time monitoring of canopy covers, and also, there are more. These are two examples for big data examples of big data instruments, publicly available. Everybody can use them and see trends and do real-life monitoring of deforestation and reforestation trends. It's great to use these tools, of course, but they tend, they tend to exaggerate maybe the potential of reforestation and afforestation, restoration, forest restoration. There is an example here in which Professor Dar highlighted claims of 0.9 billion hectares of canopy cover increases potentially being possible, large amount of carbon storage, but what we often see is that they lose out of sight the local realities. It's great to use big data, but we tend to suffer from acknowledging the local realities. For example, when we think about these big data, often they don't include land right issues, for example, or the land appears empty from satellite imagery, but if you look on the ground, there's cattle being raised. There are herds grazing the land. So we have to be careful that with these big data we don't lose out of sight these local realities, and we always need to check these local realities. I will give a presentation myself this afternoon in which I go into that more in Indonesia. The drivers of deforestation, well, we all know that. Demographic changes, I think we all know that. The big drivers, of course, are demographic changes, economic developments, infrastructural developments, and things. Those are. It speaks for itself. I think this slide. Agricultural expansion clearly is a key driver of deforestation. Now, if we look at agricultural expansion, indeed, we have to look at: do we see the big companies doing this, or do we see smallholders and poverty-driven deforestation or corporate greed deforestation. You can have divisions between that. And yeah, so what do you want to act upon most urgently? Luckily, we see some great initiatives being out there. There's the Bond Challenge, restorations of large amounts of trees, landscape. It's basically landscape restoration. The Great Green Wall Initiative from the United Nations. What we want to work on in our group is agroforestry. We see that agroforestry might also be a solution for engaging with deforestation and reforestation efforts. On the right, you see traditional agricultural system. To the complete left, you see a forest, and in between, you see the mixtures of having crops in your forest, growing crops in your forest, and thereby improving local climatic conditions. You can say that you increase climate resilience by providing more, having more crops being grown on your land, having multi-purpose landscapes basically. And that's what we're looking into. Maintaining a better microclimate and those aspects. Also, there are of course the payment services for ecological services. We looked into that in Indonesia as well. How to make sure that these big commitments from companies are from the carbon credits, etc., that they really reach the ground and deliver benefits on the ground and reach local populations and actually are implemented. Some entry points for the development of big data applications. Of course, the great advantage of these big data applications are the monitoring, real-time monitoring of forests and threats and calamities. We can look at the water stresses, risk for fire, associated risk of fires, plain deforestation. We can identify suitable sites for reforestation. And lastly, we can monitor and vary and look at agroforestry systems and how they produce the carbon stocks in such systems, and how they compare to traditional agricultural systems. We're left with a brainstorming framework here. I think that will be the discussion I would like to spend some time on with you. What do you see how we can maybe work together after this brief introduction? What do you see as interesting fields to fill in such a framework? That's it. Yeah. 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 Sorry, I'm very sorry. I don't know either. I fully agree with you. Exactly. Many times it's a governance issue, and that exactly. Yeah. The primary problem. Yeah, good. Exactly. And I think that's well, we see that that's a problem with big data. You can analyze the satellite imagery, but what's truly happening on the ground and what are the governance issues? I'll be happy to write it down. I'm going to write it down, but of course we know this one as well, but it's clearly an important one. Good. Any other? Yeah. 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 Yeah, it's about all these trade-offs, exactly, and discovering the trade-offs in your production systems. Yeah. Yeah. No, exactly. We change from optimum growth exactly towards balances between growth, and also exactly some crops grow faster than the other ones. So how to deal with that, and planting patterns are another aspect related to agroforestry system or intercropping. It's generally intercropping. Um, yeah. Yeah. Okay. I will write them down. Um, yeah. Yeah. Yeah, and I know a big data thing that might be useful as well is, there are so many crops, and indeed every location is different again, but sometimes you need, and in some areas they have very specific trees, and you don't know all the variables associated with that specific tree, but there are comparable, species which are fairly comparable. And I think it's already with ICRAF and those organizations, they have their basic databases, and that's big data as well. And you can use those big databases to get your reference material. And I know there are models. We are currently engaging with a company in the Netherlands who are modeling land use change, so these kind of things on a large scale with different types of land use cover, but also on plots and seeing the diversity, modeling different, developing scenarios. And that's what we would like to offer to students as well soon, is, and here in the area as well, is going to farmers who are locally doing intercropping or agroforestry, whatever you want to call it, and then verifying these scenarios. So what you do is you take your species and your data about it. You go to the farmer. You go and test. You go and discuss these setups, these scenarios. You go and discuss them with the farmers. What do you think? Can we practice them? Can we implement them real time? That would be wonderful, of course, if farmers are really implementing it. But do you think it is a right scenario, or do we make silly mistakes in these scenarios? What do we include and what do we forget in developing these scenarios? So it's a model from somebody else, but we would like to test it and have students work on that. Yep. Yeah. Yeah. Yeah, no, exactly, and I think that's it as well. You always have farmers who are more interested and farmers who are not interested, and if you can build these good cases and inspire that to farmers, inspire other farmers with that, then maybe we can go from there.
Are you aware of any farm management systems, preferably open source for agroforestry? Because you are talking about big data, but you have to collect data.
Yeah.
Even on a, let's say, on a farm scale, I would say, right, on local scale, and maybe not at one place, but on 1,000 farms. And so to first gain knowledge on, let's say, crop choice, crop combination, climate effects, yields, and then to apply later on this big classical big data machine learning kind of approach to see if you see some correlations, multivariate statistics in how to improve, let's say, the crop yield or the quality of the soils. Are you aware of any such system to data, spatial temporal data, management data, decisions you are taking on the farm, how much labor do you invest,
Yeah.
which measures do you take for plowing the soil and so on. Right?
Yeah. No, those are the interesting things. Yeah, you can do the gender component. You can put that in. Who is doing the labor? Well, you can also then who reaps the benefits. But those are interesting. No, I think exactly. It took us. I worked with a model provided by this company. It was a consultancy for GIZ in Indonesia, in which we used a model, and we needed to get the data as much as possible from the field, so as to get the real data from the field to work with the model. And of course, we added to that these standard findings. Can become, the more interesting it will be to work with. But I don't have a tool. I know Kobo Collect. It's just a very simple application, open source, and you can ask your things. What's the market price for this crop? What are the yields for that crop in this specific area? So that's what we can do. That's what we can put in. These variables we put into the model.
Of course, our background here is partially also geoinformatics, and
Yeah.
there is a master thesis going on, basically aiming at such a system to support, let's say, small-scale farmers to basically convert to agroforestry and permaculture, which is similar to me.
Okay. Yeah. Exactly.
Means we would set up kind of spatial database, temporal components, but also management components. And it would be fantastic to discuss this with you.
Sure. I will be happy.
First instance, we would just basically set up a system to collect data, and later on, when we have, let's say, 3, 4, 5 seasons, we could maybe then derive some rules or some insights. Right?
Great. Great. Can I have your name, please?
My name is Rolf Becker.
Rolf Becker from
From here.
here. Okay. Good.
And another point I would like to make, I like to draw your attention to a formerly ESA project, European Space Agency.
Okay.
It's called Agroforestry, and this is aiming at large-scale detection of reforestation potential. So this project has basically 4 columns. The first column is get a rough overview of where reforestation could happen. The second component is that's rather an overview, and that's for it's for free. The second component is get a closer look. There you need also commercially available high-resolution spatial imagery, which is expensive. Let's say 20 centimeters resolution, but there are some commercial companies selling these satellite images, so you have to pay for it. The third component is basically to manage the reforestation and the logistics, because when you want to plant 1 million trees, you have to get them from somewhere, and you have to transport them somewhere, and
Yeah.
then you will need a kind of aftercare. And the fourth component is basically dissemination. And the system has been, and that's for free again, so it's basically a knowledge component, you could say, right? Learning component, knowledge component. And this system has been built by the company Terrestris and Mundialis in Bonn. So there are also
Okay.
partners from us.
Okay. No, great. Thanks for that. I'll be happy to have a chat some other time and learn more what you are doing and how we can work together maybe on this.
We're searching for partners actively.
Good. Great. That's great to hear. Okay. That's it for me. That's fine.
Brilliant. Thank you. So, welcome from my side. Good morning. Yeah, my name's Katie. I'm also from Rhein-Waal. I work here. And I'd like to bring you on a bigger picture today, talking about food system transformation, because that's a topic which brings a lot of people together at this university. Yeah. Oh, so what did I just do? Okay. So we've, for the last 2 years, we're starting to create a a network between different professors and members of this university to focus our research more on transforming our food systems. So we founded a Sustainable Food Systems Research Center. It's about, I think we're 25, 28 people now involved, so some colleagues here in this room as well are member. So we're aiming to develop more projects all in the area of sustainable food systems. And I'm coordinating this center partly, and so I'd like to give you an introduction how we came up, why food systems, and then also discuss on possible what topics could we work on, thinking of big data as well. So from the start, I have to say I'm not an expert in big data at all. I come from a different background, so I just want to put things into perspective really, and then see what kind of topics we could potentially work on. So food is, why did we come up with this topic in the first place? So why do we eat what we eat? So if we think globally, the diets are just so different on the whole planet. So thinking of maybe people in Germany, in America, in Asia, it looks completely different. And if we think a little bit further on, actually why does this look different? There are tons of million factors involved. So in this slide, you can just see a few things. It's what can we grow in a certain area. It's influenced by our culture as well, by legislation, by policies. There's tons of millions factors involved. So it's not just I feel like having this. We are completely influenced by tons of different things. And that is a basic idea. So coming to food systems, we can't just look at one singular thing. It's all connected. So here's a basic trying to define food systems. It's all these interconnection. It's basically everything. So we of course we have the chain from production to consumption, but we have all these influencing factors like governance, power relationships, the inputs we need, the waste generated. It just all belongs together. So this is also this picture I like quite much. And then if you just look at one thing, you realize about all these interconnections. If you just look at growing a plant, you need the soil is important, but also the sun, what's the water? It's just everything. So this concept of food system wants to highlight these connections and try not to see things just in a narrow way, but always keep a broader mind. And this slide, where I know you won't see anything, but that's exactly the point, that you cannot see everything, just wants to show you the complexity. So what is everything involved? And that's why it's also a great concept to base our research on this, because all of the different groups at a university can find their little piece, but still we are connected, and so we can also work together, and also additional partners coming externally. But just to make it a little bit simple, what the main elements, we still have the typical value chain from production to consumption. We have the inputs we need, and then also waste and losses which are generated. We have the boundary conditions, like political situation, economic factors influencing these processes. We have global drivers, like how does the population evolve, climate change, these all also influence the systems. And then we have different outcomes. What are the results? And in theory, I really like this paper a lot, because theoretically our food systems can help us advance our health and also ecological sustainability, but currently they are threatening both. So I'd like to just show some examples here, and this is becoming just really more known across the whole planet, and it's not just now the researchers or people working on the ground knowing our food systems are in trouble. Also businesses, it's now global. Everybody knows it, especially with the war in Ukraine happening, with the pandemic. We see that value chains are easily disrupted, and that it's all connected. So just to highlight some of the big challenges we're facing and why actually I think we're all working here is first food and nutrition security. So we've actually got a triple burden of malnutrition. We always think of, which is these three different things. There's obesity, there's undernourishment, but there's also a lot of hidden hunger, and it's so many people on the planet being affected by one or two or both in these. And even depending, in some countries you have both two problems or three problems, all these problems in the same, in the same country. And it affects, about 1 in 5 death is due to unhealthy diets due to one of these issues. And also a topic we need to address, I mean, there's concerning our social well-being, where the population is still increasing. So on the left you see the trend with different estimates how the population will increase for the planet. And then on the right, it's the calories required. So we will need still in the next upcoming years more food. We still need to produce more food to help our to just sustain our growing population. So that is a challenge with the areas we have, especially considering due to climate change, there will be less land available to produce this food. So this is an estimate on which areas in future will drop out. So we will not be able to plant crops in certain areas anymore. But on the same time, our food systems also have contributed to climate change a lot, how things are done here, and especially, I think, as we all know, is different livestock systems, which are responsible for a high amount of the emissions caused. So these are the big things I think we want to talk about, and there is no easy solution. I think we can all agree on that, and I found it great to hear about different solutions. So just a few things coming back to this food systems approach. It's just to bring you back to this way of thinking, to keep these connections in mind, and that with that we also need to change a bit how we do things. So not just think about just in the box on my little topic, but keep always in mind what does it affect. If we develop a technology, how could this impact other things just beyond that? Not just focus on the solution, but also think how could it affect other sectors, the working environment, etc. Another point I'd like to highlight: the systems are so different all across the planet. So we have this big industrialized agricultural system. We also have in many countries it's based on subsistence farming. So there will be no solution fit for all, but we might need to think of different things. I mean, diversification might be a key for both. But also if we develop one solution, also think for whom is this for? Can other people benefit, etc. And this slide I actually really liked as well. If we think about one solution, where does it actually lead to change? So in the right, if we think, does it just change the system a little bit, like make it more efficient, or does it really transform the general system, how we produce and sell food? So there are different approaches, like I think a lot of the smart farming, precision agriculture is a lot about increasing the efficiency, but it's still, the system stays more or less often the same. With the industrialized agriculture, we need less resources, but it doesn't really change the whole way we live. It just makes it more efficient. So there are different levels on how can we maybe really transform things. But now I'd like to think about some solutions, which are maybe probably key areas we should focus on. So one is reducing waste, because about a third of the food is wasted. Depends also in different countries how much food is wasted, also at different levels, but even just alone I think at consumer level is about 30%, I think, in Germany. So there's a really high potential there. And then decrease or livestock production, because they have just such a high environmental impact. And then diversification is key, like for example also agroforestry, to make our systems more resilient. If we have these big monocultures, they're very susceptible to diseases. And then, why we're here today, also smart use of technology. So also in breeding, which is a lot in this CRISPR-Cas research, or big data, digitalization, there's a lot of potential also here. But I think we need to think of everything. I don't think there's one solution, but we have to, they probably have to tackle things from different angles, and we need probably input everywhere. So talking about, when I researched a bit about this presentation, came about a nice review on big data applications which already exist, which are already researched upon, and there's a lot out there already. So there's found this nice review paper. So there's a lot with sensors, robotics, with also control systems. There are various different possibilities there. I'd like to highlight a few which I've visited some last year about precision agriculture, which just focus on how to reduce input needs in a system, and where you might need less fertilizer or pesticides, because you actually really can measure what the plant actually needs. So just two examples where I was visited last year. So where they measured some the height of wheat in a field by a laser measurements. So on the picture on the right, you can see the different heights of the different plants, and that can help facilitate if you have breeding programs, or see if the plants are if they are stressed or not, and you can adapt then the management. I was in Zurich last year at the ETH center where they did this research. So that was. I'm sorry I haven't been to your sites yet. Otherwise I could have showed those. But I had some nice pictures there, and also they had a study on nitrogen, where they used remote sensing data and soil data, and then actually could really modify the amount of nitrogen fertilizer, and they showed that they could increase the yield a bit, and they needed less fertilizer. So these things work. There's a lot of research being done, and which I think is great. However, I think there's still some challenges which I think we also need to address, because I think, as I mentioned before, does it really change the system, or is it? I mean, it makes it more efficient. I think we need it, but is it enough, or should we put all efforts in this box, or should we also look at other? What about the smallholder farmers? It will not change the power. We had the issue of power in the presentation before. Will it just be the big players being able to use this? How can also smallholder farmers benefit from these new technologies? So I think these are big questions we need to also think about and address. And then there's also, how do we go on about data ownership? Or example, if there's a problem if a system doesn't work and then there is excess pesticides, is it then the farmer's fault? Is it the software? It's the fault of the software developer? There are maybe some things which are still challenging. There are also other applications of big data in food systems, which are more looking at the supply chain. So there is potential to make it more efficient, to avoid losses, also to increase the transparency, where I think we're hearing some examples later, and where we've also tried to develop some project proposals, but unfortunately they were not granted. But there are tons of possibilities which I do not know about it so well. So that's why I'd like to actually facilitate the discussion now, because what the aim of our center is, what are potentially solutions we could focus on in our work, working together in a collaborative manner, having the systems perspective in mind. So what approaches make sense, where could we work together, and which make the most sense, which would create the most impact. So this is just our mission vision statement of the center. So we really like to make practical solutions which tackle these challenges and create an impact, and as I try to illustrate, work together in a team effort, having getting the different perspectives in mind. So just as I've put 3 questions here. So from your opinion, so which approaches, which technologies make most sense? Where could we focus on? And what are potential challenges, but where could we work together, bringing our different expertises together? So, thank you very much, and I'll leave it here.
There are 3 questions to the audience.
Based on what you said about data and data availability, data ownership, maybe just an impulse from the Nitrate Scouts project. We had an interview yesterday with someone from an authority
Mm-hmm.
Regierungsbezirk Unterfranken, that's in Bavaria, south of Germany. And he said, also in the past already, one of the big problems was to really get on a land parcel scale data about, for instance, nitrate soil emissions, nitrate soil contents, which could then be linked to the groundwater concentration. So I think, data ownership
Mm-hmm.
is probably a big issue to discuss.
Mm-hmm. I'll just have my notes.
Was it a problem of the allowance of taking the data, or the instruments, or the publication of the data?
The willingness to share the data.
From the farmers, or? Okay.
So you need policy enforcement arms to. In the Netherlands, they have to close down some of the cathode green soil, right?
I think, of course you need legislation, you need rules, but forcing people is not always the best of all solutions if you want to get real collaboration.
Hmm.
But I think it's an issue which needs to be discussed.
I mean, we've started to talk to some farmers also with this agroforestry projects we're starting, and farmers are very diverse as well, and some are really open and we'd like to work, we've got land, please help us, let's do something, and others are no way. Yeah.
If farmers get funding from the government, part of the deal could be, okay, you get funded back,
Mm.
you have to share some of the, the data we can
Yeah.
get from you.
Yeah. Some are even just, no, we've got land, please do what help us make it more fit for the future, develop a plan, and but that could be a possible way. Yeah.
I just talked a bit about agroforestry myself, but I saw one of your slides, like the subsistence going to agroforestry, the other one going to agriculture.
Yeah.
I don't really think that's a path forward. If you have your landscape, or how do you judge the highlighted approaches? Well, I don't judge that approach as the desired option.
Mm.
In different landscapes, you might want to go for different approaches.
That definitely, yeah. But I think well, if coming from the big monocultures, I think some kind of diversification is probably needed if there's a weed, if there's a disease.
There might be other
Yeah.
areas where it might be
Yeah.
a relevant option,
Yeah.
because also we need to produce and feed those populations.
Mm.
Feeding everybody from agroforestry, I'm not sure that's going to work either.
Yeah. Yeah. Yeah.
Can be on your team, right? A question for my, my technology expert. It says, the third question, right? It says, what would be potential challenges keeping a systems perspective in mind? Thank you so much for mentioning all of the systems that are already exist. The express our problems.
Mm.
What do people think at the level field? No? Something that someone who's not there does not know. My question is, at the day end, when we try to implement such a system, no? Whether it's agroforestry or anything that's related to agriculture, we're basically tending towards developing countries,
Mm.
farmers who are less educated than we are. And so one of the problems that we face basically on an average is that from the technical side, they're not so educated. No? It's better to step into their shoes, even if they probably don't have shoes.
Mm.
And to think that how can you make it more user friendly? That's one thing. And another thing is that when you tell me, okay, you can use this device from tomorrow, the first thing I said, no, I don't know if something's going to explode or something, because that's the way they're thinking. So how can you make it more user friendly? It's not just about the languages. Sophisticated, devices we can probably use, all of us in this room. But somewhere where we're applying this stuff, it might not work. So as technology experts, our request would then be, could you please provide us, and you've done a great job. So far, you've done a fantastic job. But these are the things we require for us to implement such things. Because at the day end, we're all here for information, right? And that's what Katie's probably saying. So she said that to get to the grassroots level from the farmer, when we're telling them that, or asking them, hey, could you please implement this for us? These are the benefits we provide. They say no.
Mm.
Sometimes this is because it's not user friendly. So, if you could, considering the existing situation, one of the challenges is that trying to make this technology more user friendly. And this is why it's, although you have something, sophisticated and you showcase it at different places, it's not applied so much yet. So, our request, then the potential challenge,
Mm.
would be to make it more user friendly.
Mm. No, thank you. Yeah. Now I don't know who was first. Yeah. Mm. Yeah. Those. There's a lot. Yeah. Mm. Yeah. No, it is going into that. So we're starting a big project there on creating agroforestry living labs. That's starting in March, hopefully, because I think for Germany, I think there's a big potential to get more trees onto the fields. So there's more has been more done in France, for example, and other countries. And just considering the drought, I mean, if you look at last year, the summer, the drought, bringing trees onto the fields makes sense here. So we want to investigate which tree combinations make sense. But it's also from a legal perspective really interesting. Some farmers are very skeptical because it changes the status of the field. If it's in a forest, or is it not agricultural land anymore? It changes completely how they can manage it, and that's also perspectives one has to take into account. So that's why we thought we will try to get everybody together in a living lab, to have the authorities, to have the farmers on board, to get all these different things in mind, because I mean it's great to see the carbon gets improved, but if the farmers cannot implement it because they then fall out of the agricultural scheme, so yeah, but that's a great point. Yeah. Mm-hmm. Mm-hmm. Okay. Yeah. Mm-hmm. Yeah, I'm not a expert on that, but
Anyway, but you see, it's a very complex thing, and we haven't even addressed main issues like distribution and food waste, which are main drivers of the problem. And that, of course, hinges on to political problems and so forth. But I think, as such, the silvopastoral system is not exploited yet enough and should have a future.
I think
Concerning the global changes,
yeah.
climate changes, and so forth.
I think this is a lot of research potential still here, especially in Europe and in Germany. We know these systems more from other countries, and we can still learn a lot.
Neighbor of us, Switzerland, has already much more experience
Yeah.
with it, so why not learn from them?
Yeah.
I mean, we showed one slide.
Yeah.
And that also increases biodiversity.
Yeah.
And biodiversity increases food production.
Mm.
It's simplistic, but it's true. Anyway, I don't know whether Maria could come.
Anna Maria's ill as well.
And whether anybody is going to replace.
Yes, I think so.
That's me.
I don't know what's wrong with this dance group. Very, very low.
But we're going to make it possible, no?
Okay. Okay. Whoops. Oh, I have to carry this? Okay. Oh, okay. Will this work? Oh. Okay, so this is going down, this is up. Thank you. Hello, everyone. If I'm too loud, raise your hands now, if it hurts your ears. My name is Shafi. I'm a scientific staff at the Faculty of Life Sciences at HSRW. And I'm going to present something from one of our colleagues, Dr. Gomez Valle, who could not unfortunately attend due to unavoidable circumstances. And in the words of Katie and cited by Itzart, it might be a bit of a karaoke, but I want to see if we can actually engage on this topic, but really engage on it, okay? So, the title of Dr. Gomez Valle's work is that it's a discrete choice experiment to measure the German potential market for Baru chestnut products. The idea, the reason why this is a really interesting topic is that, a quote from Muhammad Ali, right? It says that it's something more or less to the effect, float like a butterfly, sting like a bee. Your hands can't hit what your eyes can't see. So that's the job of an economist, no? Why are we still there? It's because sometimes we get, told by, technology experts and stuff like that, hey, what kind of information do you want? And our question is that, hey, the type of information we want, the ones that you guys are always, coming up to provide us, is the ones that are tangible, things that we could see with our eyes, no? But we want information that we can't actually touch. Things that, we require such information, but things that you probably couldn't see under a microscope. Okay, so that's the whole purpose of us coming all the way from Cleve to meet y'all. Thank you. If I'm going too fast, slow me down. It's just a hype. Great. And so the study focuses on the Cerrado region. So it is a region for now. It's a region where it's a biodiversity hotspot of global importance. Something that we can benefit from, a place or a region. And so the idea of this, this initiative is that this region, it provides key ecosystem services, and it's important, for us to preserve this area and to utilize the resources of the region, which also improves human livelihoods. And the problem that we're facing in today's world is that there's continued forest degradation and deforestation, as everyone has talked about. And so the focus, if we deep dive, so we understood the problems, right, of what's going on. And the solution that these authors propose is that they refer to silvopastoral systems, basically a combination of trees, crops, and animals, right? So therefore, it represents a type of agroforestry system. Why in the world are we, basically talking about, okay, the solution would be to have an agroforestry system? We're going to get to know more about that in my presentation. So that you're convinced, no? Sometimes it's the purpose, no? If you tell someone that these are the benefits that everybody gets, you as a technology expert would be more motivated to help us. And so you understand that a silvopastoral system, which is known as SPS, it's a combination, suppose, of trees, crops, and animals, right? And we combine that in a manner through a sustainable management strategy for commercial potential, right? And so, however, SPS development is currently limited because of the various knowledge gaps. And that's why we're here today, because we need information. And so you can see here that this is the Cerrado region that the author was talking about. They're more focused in the area of Brazil, right? So the country of Brazil. However, this Cerrado region, which provides numerous ecosystem services and benefits, this extends all the way up, down to, suppose, Paraguay as well. As you can see, the area that's focused in red is where this experiment is going to be run. Okay? I hope everyone's following with me so far. Great. And so based on existing literature, right, there's so many products that come from the Cerrado region, right, as you can see. There's different, suppose, species names. We have the fruiting periods, right? We have, the abundance of it, whether it goes on trees or on palms and stuff like that. And we have different characteristics, right? Because most of these products from an economic perspective, is that we think about the uses of these products. And that's how we find the value of these products. How valuable is something to us? And so this is the existing products that you can find here, right? So yeah, as you can see, but we're going to be focusing on Baru, because as you can see, we're going to focus on the Baru tree and its potential to SPS, which is silvopastoral systems. Why is that? That's because from the Baru tree, right, the chestnuts that's provided from it, it's actually not just used for human consumption, right? Some of the shells from that is used for animal fodder, right? And so, which means that it has not only benefits to humans, but as well as to animals. So at the same time, instead of just having crops, you can also, raise animals and cattle and stuff like that. And so the idea is that, like Katie talked about, you can transform these different products, right? And so it's highly nutritious, right? And it's not only used for consumption, but during the dry season when you have very little rain, right? This is actually a good alternative for animal fodder, right? So you already see that we're on the path to efficiency. Okay. From the Baru tree, the products that we extract are used for, suppose, not only for food and consumption, it's used for medicine. And it provides so many nutritional benefits. However, Dr. Gomez-Valle told me that it has a very oily consistency, so you can't have, suppose, a kilo of this chestnut all the time. But you get the idea. The trees are so tall that you have to wait for the nuts to fall onto the ground before you can actually harvest them. No? Okay. And so we understood the importance of using a silvopastoral system. It's basically saying that I don't want to put all my eggs in one basket, right? I want to include trees. I want to include crops. I want to include animals on the same, piece of land. So which probably raises efficiency and effectiveness. And the idea is that, so what kind of information do we want? The authors, they conducted a discrete choice experiment which aims to analyze European consumer preferences. So just a little while ago, I told you about, the products from the Baru tree, right? And the idea is that we don't have information, suppose, on the prices of such products, right? What is the demand for such products? Because what can be used as food for consumption can be used for medicinal purposes. So you see that the value that you probably give to the products might be different from someone who's trying to come up with some biomedicine or something like that. It's much more valuable. And so we don't have this information. And so what the authors basically did is that they made a questionnaire, and it's divided into 3 parts, as you can see. And it's used to collect primary data from German consumers of organic nuts in order to calculate the willingness to pay for Baru chestnuts. Okay? So what? So what do I do? Basically go to each individual and ask, how much would you pay for this nut? Right? And that's not the purpose. The idea is that they utilize this experiment to quantitatively understand the relationship between price and certain attributes. Okay? For example, different products they have, suppose they said that they analyze, and this discrete choice experiment, right, DCE, it's been applied in different market researches, economics, social sciences, environment, transport, and healthcare, which mean it has already gone through all the security checks to be applied. And apart from the theoretical side, because we come from an applied sciences university, the idea is that there's certain attributes that different products have. For example, flavor is something, right? Whether or not it provides environmental protection, right? Trees can provide, protect you from, suppose, the winds and stuff like that. When there's windstorms or sandstorms and stuff like that. And so based on these characteristics, individuals are asked, what's your willingness to pay because of this product? because it provides such and such attributes. So then we can understand a relationship between the attributes and the price that someone's willing to pay. So we can find the price basically for a certain attribute, or we can find the, based on a level of a willingness to pay, based on how much money I probably have in my pocket right now, which attributes can I easily acquire, which would help us to transform the products to cater, in our case, the German consumer market. So you automatically see the type of information we probably require from you, is that whether or not we can generate that, whether or not we can come up with a database for such information. So we wouldn't have to get primary data, or we can compare consumers in different markets. Did I turn it off? Okay, great. And so what we see on one part of the equation is that we basically want to see what is the, the probability of someone's selection of attributes for a certain price. So we want to find out the maximum willingness to pay. We run this through a software, and so we find out, suppose, the minimum willingness to pay for certain attributes, the average, and the maximum. And that's the purpose of, this study. Is basically to find a relationship between price and these different attributes. If we can have this in a database now, it would be great. I'd probably have something for my PhD as well. And so, if we acquire such information, this would help us to, to help resolve procurement issues, right? We can find out different combinations, like you said, of certain attributes to come up with a new product, suppose. This can help us through different stages in the value chain, including marketing. Would help us with, suppose, organic labeling as well. And it would create, it would get us a step closer towards sustainability and, improve socioeconomic conditions, right? Suppose the nutrition that people get. So with the same amount of money, people get probably more nutrition because of this information we can get. And so this work aims to investigate if a set of characteristics exist which make German consumers choose to buy Baru nuts instead of their current options. Okay, so the idea is to provide consumers more based on this, better options and more nutrition based on the same amount of money that they're probably paying for organic products at the moment. And so, yeah, the survey covers individuals from different regions in Germany, based from an age of 16 to older, who are the current buyers of these organic nuts within the German population. And yeah, so this gives us an indication of the market for Baru chestnuts in Germany. Okay? And these are your references if you feel interested. Please have a look at these. Now, this is the last look. This is the condition, which means we have idle resources and we're not utilizing it as efficiently as we could as civilization. I kind of like the one in the back, the cow in the back. So, okay. Anyways, now it's your turn. Please.
Thank you so much for this very interesting presentation, also in the karaoke style. I really enjoy it.
Mm-hmm.
To be honest, I'm so sick of surveys. How do you make people contribute to it? Wouldn't you think maybe a gamification could help?
Yes, we do have bidding games where we say that, okay, there's like within this situation, like first of all, this is the idea. At the day end, we try to sit on a chair and think about what can we make with the survey, and then you're sitting out with the farmers, really in, suppose, somewhere in Central Asia or Africa, and you're sitting down under the sun and thinking, how do I get this person to play? How do I get them to express the truth? As you can see, the idea of this project is not the producer side, it's more of the consumer side.
Yeah, but still, how do you get the response, right? Usually you have a poor response when you do surveys.
Basically, what we do is that we say at the day end, we talk about the benefits of suppose, our initiative. So, for example, when it comes to agroforestry systems, we have questions like, oh, why is it beneficial? And at the day end, if you tell a consumer that, okay, these are the benefits you get from participating in our survey, people are the ones who are thinking better for the environment. On an average, we do. But we're not ready to pay. Now, if I tell you, do you care about, protecting the world? You say, yes, I am. But if I tell you, are you willing to pay for that? Right out, you'd say, I'm a bit skeptical. It's getting out of my pocket. So the first initiative basically comes from the government. Now that's the first solution. The government takes the initiative, but gradually you understand the benefits of it. So then you start purchasing those commodities. But that is a challenge, because I tried to run a survey myself, and it was really hard for them to participate. So yes, you are right that it has to be incentive compatible when it comes to surveys. Yes, please. Yes. Yes, please, sir.
Yeah, thank you. I was wondering, in this data model that you presented,
Mm-hmm.
as far as I understand, there's a number of variables that contribute to the willingness to pay to consumers
Mm-hmm.
that are accessible to them, so that they can indeed put a value on, let's say flavor. Right?
Mm-hmm.
You mentioned that as an example. But then there's a number of other variables that they cannot possibly have an opinion about. Let's say the medicinal value of the plant.
Mm-hmm.
So how would you cover either one of those values in the same data frame?
The idea is, when you use, of course, this is someone else's work, but just to shed some light on these approaches, what do we do basically? From such an approach, all we can do is find out what happens on an average. So it's an average indication of what the population thinks. It's your perception of what you already know. The idea is that within these experiments is not just asking you, okay, what's your willingness to pay? They give you a hypothetical example. They create a scenario where you have to actually make these choices. No? I completely understand what you're saying. And the idea is to make the questions as simple as possible. No? Basically spoon feeding the reader, so so on an average, suppose the 16-year-old would understand what you're asking. When you and I are talking, we're talking from experience, and maybe it's at a different level. But yeah, the idea is to find the answer on an average. That's the thing. Please.
I'm not sure. What about average? Is average where you what you want, or maybe you want to go to the extremes?
Of course, but that's the idea, no? We want to see what occurs on an average, and then we can manipulate the probabilities. So what is the probability of me making a certain amount of sale in Germany based on considering conditional, right? That's why it's conditional, on the attributes that the German population prefers on an average. I'm sorry, that comes from an economist, because when we think about, suppose, an initiative, we have to think, you see there was a commercial potential. So commercial potentials has to be something that really everybody, most of them prefer. Sure. Okay, so the idea of, suppose, such a regression, no? When you're using this discrete choice experiment, is that, all of these coefficients that you see, right? So for preferring a particular attribute, what is the coefficient? Which means basically you're considering all the other variables are constant, and only this changes. What is the impact on the value that you put? Basically a relationship between independent variables and dependent variables from a multiple regression perspective. We can talk about that later, but I'm pretty sure I don't want to hold everyone up for it. But there's a solution for that. Questions? Tomatoes. Sir. Yes, it's been exported. Mhm.
What about the current evidence? Is that in principle something which promise certain success?
The first answer would be I don't know, to be honest. But the second thing is what can we do? The idea is what can I do with such information? I can understand which attributes you really give importance to. Suppose this class was the German population, right? Which attributes do you consider the most important to yourself? So I ask you, is environmental protection important for you or something else? And I know that this product has these products have such attributes, but you can't see them. But I know what you prefer. And if it does contain that, when I market it into the market, I will mention, it's environmentally friendly when it's grown and stuff like that. Some things that we use in organic labeling. So sometimes, it's just basically licking your finger and seeing which way the wind blows when you don't have all this information. But to know that, okay, these are the attributes that you preferred, right? I can actually highlight that first so that it, makes it into the market even quicker. Okay. Any other questions? Thank you, audience.
Okay. So, my name is William, and I guess if you look on the program, it's a little different, the title of the presentation and what is projected. Yes. Let's go with this one because, yeah, I think we've heard a lot about big data, and so the decision lately was to present something that could also generate some more interesting discussion, looking at the background of the people that we are likely to meet here. So
this presentation is going to look at some highlights that we picked up from a project that we've run for almost 6 years at Hochschule Rheinval, and then see some areas that could be potential for some collaboration based on the knowledge base that we have in the room here. So I'm going to talk about the baobab industry. Like I said, we've done this research for the past 6 years, so we have quite some interesting information that has come up. Yeah, I think it will be fine to talk a little bit about what we mean by baobab, because I'm not too sure if everybody knows about it, like baru, that was mentioned just by the previous speaker. So this is how baobab looks like. So it's a giant tree, as you can see over there. Okay, yeah. Oh yeah, okay. So as you can see over there, on your extreme left, it's a giant tree that is found all over sub-Saharan Africa. And per some research that has been done, it has about 300 uses. But basically, the one that is in commercial production are two. It is the fruits. Okay, so the pointer doesn't work. So it's the fruit, as you find in the second picture, or the middle picture. And then you have the oil, which is extracted from the seeds that is found within the pods of this particular fruit. So these two products are on commercial production, and they are not only on the African market domestically, but they are also on the international market, and we have them here in Germany, in Netherlands, in UK, so I would say on the European market. Some are also on the Australasian market, and some on the European market. This fruit has traditionally been used in local communities in sub-Saharan Africa, but following some innovative research that took place, some very good products were generated from this, and that's why it found its way onto the international market. And it's marketed as a superfruit, which is landed with a lot of nutrients. So you think about vitamin C, prebiotic, it's prebiotic because it's already in it, it's natural. You have phosphorus, potassium, and many more nutrients. And that's why it is marketed as a superfood or a functional food that you can really derive a lot from organically. Now, this particular product, or this particular fruit, like I said, for the past 4 years, between 2013 and 2017, different companies have tried to incorporate it as an ingredient into their existing product. And per some research, about 53% growth rate has been observed within this period, where companies like Coca-Cola and other big companies have incorporated such ingredients into their existing product. If you look at the projected market performance, for the next 10 years, between 2017 and 2027, in terms of value, we're going to record about 6.3%, and in terms of volume, about 2.6%, only on the Western European market. Globally, the value of this particular value chain is going to increase up to about 9.3 billion euro. So that's quite an interesting outlook for such a tree or fruit that is found locally within the sub-Saharan Africa. But again, if you look at many industries around the world, it has its own share of challenges. And this is what this presentation is seeking to highlight and look at how IT solutions can be used to address this problem so that we can continually improve or develop this particular market baobab industry so that it can serve as income for the local people within Africa, and again, for investors to also generate something from. And so exactly what key challenges are we going to talk about? Just 3 that we think probably we can get some very good suggestions from you and see how we can take it further. First, we'll look at resource assessment, challenges, and then we'll look at product quality and safety, and lastly, we'll look at issues of traceability. Like I said, there is demand. There is increasing demand for this product, not only on the European market, but Australasia as well. And so you would think that if there is such increasing demand, then as an entrepreneur or as a business in this particular industry, you'd want to know your resource base and know whether you can meet this demand projecting into the future. But the unfortunate thing is that even though the market is driving upwards, but there's very little information about the resource base of this particular resources that we have. So what exactly do we need to be able to address this particular challenge of resource assessment? Of course, this will come from you as we get into the discussion session. But I think my responsibility will be to highlight some key areas of resource assessment that we need to focus on and see what kind of technologies exist to be able to address this. And that's what I'll do in the next slide. So I think it will be fine to first of all look at the picture and give you an impression of the resources we are talking about. So this is the baobab in its natural landscape, very scattered. And look at the way the tree is shaped. And this you need to assess and know your base. That's not the only challenge you need to face, because this is in the savanna landscape where it is dotted all around. The other thing is, if you want to scale up the production, of course, develop this industry further, it is not just knowing how the trees are placed, but what is the yield level of these trees, because you are focusing on the fruit. So you need to also think about the average production of fruit per each tree that you have been able to survey. Now, after doing that survey, you also need to look at the fruit itself, because you're going to focus on the powder, which is one of the key products that is processed into other products that are put on the market. So if you pick one fruit on the average, how much powder do you think you can generate from the pulp? Now, the other product that I talk about, which is oil, which is extracted from the seeds, you also need to think about it. If you take a kilogram of seeds of baobab fruit, how much oil do you think you can generate from this? So these are key resource assessment questions that need to be addressed before we can further develop this wonderful superfood that we have going into the future. And this is where we will need the big minds in ICT or information technology and others to be able to come around and see what can be done. Per my own brainstorming, I thought maybe geospatial technologies could be handy in doing this continent-wide assessment. Can GIS or remote sensing tools or technologies that we have, or techniques that we have, be able to use in doing this resource assessment? Can we geotag the trees that we have so that we can monitor consistently from year to year, from season to season, how they are producing fruit, and also know their health and things like that, and also learn about their structure in terms of population. So these are big issues that needs to be addressed. And again, it is the entry point for some of the big minds here, and of course the experience that is within the hall, to see whether some of these technologies can be used, which I don't know of, or which probably I might have highlighted based on the general point that I put there in terms of geospatial technologies. Okay. We move on to the second challenge, and this has to do with contamination. And there are two kinds of contaminations here. We have adulteration, which is normally called food fraud. I'll explain that briefly. And then we have the microbial contamination. So let's first of all talk about contamination in terms of adulteration. In the food market or in the food industry, people try to make economic gains by adding adulterants to an original product. The aim is that if I have a certain quality and I think that it's very difficult for me to produce this quality because of the high cost, and I have a similar product that is very comparable in characteristics, I can mix this with the original one that I have, increase the volume, reduce the cost of production, sell it to the consumer, and I make a lot of money. Now here there are two problems that comes up. One, you compromise the quality of your product. And so the intended benefit that a consumer should get from the original product is limited. So it is kind of a cheating to the consumer. But this is real. It is real because some estimates have shown that around the world, we lose $49 billion annually because of food fraud or adulteration. And already there are issues or instances that have been found with adulteration of baobab powder on the market, where people mix the original powder with wheat flour, with maize flour, and with rice flour. And it's very difficult to determine physically by looking at the powder and say, this is an adulterated baobab powder. So how do we address this challenge? Because this industry has the potential to grow, but with compromised quality, it is bound to shut down. Some brainstorming that I did, or some research around, some research that I conducted showed that there are technologies like spectroscopy that can be used to actually help in detecting adulterants within foods. But is it cheap? Is it affordable? Because we're talking about small scale entrepreneurs in sub-Saharan Africa who are into this kind of production. Of course, there are some medium scale enterprises around the globe, especially in the UK, in South Africa, and in Italy, who are into this. But would they be able to afford such a technology to be able to detect whether this is an original baobab powder that is put on the market? So again, this is where the brainstorming session comes in. Do you think these technologies are enough to be able to help in detecting adulterants within the baobab powder? Can we use these technologies to determine the quantities of the adulterants? Do we have rather an affordable technology that can help the cause? Again, it's something for us all to discuss in the section when it comes to the discussion. Now let's talk about the microbial contamination. So as you can see, this is a powder. And maybe your level of experience tells you that if you leave powder on the open for a while, it is hygroscopic, and so it is likely to absorb moisture. And that's exactly what baobab powder does. It absorbs moisture. If you have high moisture content level, it opens it up for microbial contamination, because that is a very good environment for microbes or mold to grow. So it is one of the problems that entrepreneurs in this particular industry also face. So they need to find a way to find the optimum moisture content level to be able to package it at the point that they can prevent the microbial growth. Now, when it gets into the packaging material, also, they need to find packaging materials that can also further prevent absorption of water within the environment. How can this be done? How can we produce materials that can be used for packaging purpose that can prevent further absorption of moisture within the environment? And then before we get to that stage, how do we even determine an optimum moisture content level that is good enough to guarantee the quality that we need before we package? These are burning questions that need to be addressed. The entrepreneurs that are already existing have found ways to address this, but it's not enough, because we're talking about large scale and looking at the production. You can't still be doing the very low level of stuff to be able to get to make bigger sales. You'll still be in that small room doing the very little things. But this industry has a potential to be big, and that's why we need to consider this. Again, what can we do? What options are available? Like I said, can smart packaging materials help? And what do we mean by smart packaging materials? Of course, you know better than me if indeed you work in this area. Smart dryers, where we produce some very simple tools for these producers to use to be able to dry the powder at a certain level that will guarantee them that optimal moisture content level that they need. would these dryers help them to know that yes, you have reached the maximum point or you have reached the optimal point, and so that's enough, so you take it out and bring in another. So yeah, I mean, different kinds of ideas come into mind. And again, this is for everyone to think about and see the entry point for this based on our expertise. Now I talk about the last challenge, which has to do with traceability. There's a big talk about transparency in supply chain or value chains. Consumers want to know whether the product I'm consuming is sustainable in terms of its sourcing, in terms of its processing, whether it is wholesome, it's of good quality. And then the regulators and the standard authorities also want to know whether all these things have been done. And so there is a cascading effect right from the farm level all the way to the consumer. So it's kind of a supply chain from that person to the last consumer. And so the issue is, how do I trace what happened at a place where I was not available? At the producer level, I was not there as a consumer. At the processing site, I was not there. Of course, you trust the standard authorities or the regulators to regulate this. But anything can happen on this way as well. So is there a system that can guarantee or provide that guarantee that all the important steps have been observed right from production level until the point where you as a consumer picks it from the shelf and use? So this is a big question. How do we coordinate all the supply chain members? Do we have to look at supply chain digitization to be able to have this kind of information that we need? So what kind of technologies can be used to address some of these issues so that we can have some kind of traceability within the system? Do we think something like a blockchain technologies can be useful in these issues or not? And how can this be done, looking at the fact that these are small-scale producers, small-scale processors, and small-scale marketers who are within these value chains? So these are the three key issues or challenges that we found after going through this project and working with different industry players and then enterprises that we think provides another level for us to continue with this project, but this time looking at how we can bring in information technology or other technology to be able to address some of these issues and help the industry to grow. And so in the brainstorming session, I thought of providing some kind of a framework or a format that can help us to guide our thinking in looking at some potential areas that we can collaborate to bring up projects to be able to address some of these issues. And so this particular table just repeats what I said in a very summarized form. So you have the challenges and the scope over there. So we talked about the limited resource assessment and management, the adulteration, the microbial contamination, the traceability issues, and then some of the technologies that we think are available, some we know, some we don't know of, and the kind of information we require to be able to do some of these things and be able to address some of these challenges. So briefly, this is what I wanted to present to you, and then hear from you what we can do. Of course, I'm also here to answer all the questions for clarification to be able to determine exactly what kind of contribution you think you can bring on board. So thank you very much for your time. Yeah. Okay. You can go. You can pick anyone that you are comfortable with, and I'll do the. Just a moment. I need to pick my notes. Yeah. Okay. Thank you for the patience. All right.
Okay, yeah, I do have some ideas about this. And thank you very much. It was quite interesting, yes.
Yeah.
Well, for starters, I always tend to think about many of such
Yeah.
the same thing as we learned before. In the case of the yield of the fruit as well as the oil or the powder, of course that's well, that's a function of many different variables. Some of which I'm fairly certain can be assessed by remote sensing. Let's say geospatial analysis with satellite images. Others would rather be in need of detection on the ground or would require some calibration. But either way, let's say that's general climate conditions, soil conditions,
Yeah.
then some wildlife influencing maybe on conditions of the specific trees, all of which together have an impact, a partial impact, a share of the impact on the total yield of the plant. And in this sense, what we just learned in the previous presentation would be extremely helpful to combine all these factors in such a regression analysis. And that is indeed also one of our particular interests. We're trying to use these analyses, these statistical analyses, for a whole number of different applications, and this could be one of them. Then about the adulteration, the impurities, purity detection of the powder. Indeed, from my understanding, FTIR could be a reasonable application. Matter of fact, we do have one.
Oh, okay.
So what could be helpful would be the establishment of a sampling system. Apparently, I would not go into the field and ask every single Baobab farmer to hand over a sample, ship over a sample to us or to some other entity to do the testing. But I would suggest this chain of tracing for impurities to start with intermediaries, with the first intermediary traders. All of which would have to be obliged to turn over a sample from all the deliveries that they receive the moment of reception, to make sure that they can wash their hands clean. Yeah? Because well, if you do it that way at any stage of the supply chain, starting at that very moment when they receive their deliveries, then it should be able, including blockchain technology, to trace back where has the impurity
Come from.
been committed.
Yeah.
Yeah, that's about it. Blockchain technology, yes, from my understanding, it is possible to be applied in such a supply chain at any moment where the good is being delivered, these nodes where a good is being delivered from one entity to the next. That's why I had this idea to do it at the very moment of reception.
That's fine. Well noted. Yeah. Okay. Yeah.
Adulteration, you said that it's mostly other flowers,
Yeah.
like
Rice, maize. That's correct.
Atoms are very different from each other. You can do it with a simple microscope. In a simple microscope, you can construct with a cell phone. And so the first one in that purchases the materials can already look for that. It's very, very simple. Every child can basically do it. They are so different from each other, starch grains. And you don't need a big magnification. So a very simple self-made microscope will do it in terms of flowers. When it comes to oils and so forth, it's a bit
Difficult.
trickier. But as a first observation, it's everybody can do it actually. You can learn that in 5 minutes, differences between starch.
And yes, one more thing about packaging.
Yeah.
I was wondering if we could use our precious plastic ideas to produce packaging material out of old reused recycled plastic. Should be possible to do.
Okay. But again, I think the watchword is that it's also about affordability. and how easily accessible some of these techniques and tools or materials are to the small scale producers and entrepreneurs. Yeah.
See, that's the nice thing about the plastic.
Yeah.
You produce the packaging.
I don't know which is, yeah.
So that's, at least the material feed comes for free. Now the machinery, of course, that would need some initial
Energy.
investment, but in the long run, it would pay off.
Good.
And about the microscopes that Ralph mentioned, I once participated in another workshop where we learned how to fabricate microscopes based on very cheap material from a simple webcam. That could also be connected to the internet and transmit the
Data.
imagery to some controlling certifying agency somewhere in the world. Now, it wouldn't matter.
Great. Awesome. Okay. Okay. Okay.
Yeah.
Yeah.
Normally with powders and little buffer that's mentioned that you can use it microscopically. It really depends on if it's at the source or if it's the final user point. I mean, you can use much more sophisticated techniques if you're just checking that the powder you're receiving
It's authentic.
somewhere else.
Mm.
It's added. So in that
Yeah.
case, I don't think one has to resort to relatively simple techniques, so one can go more determined. The FTIR and NIR technologies, they are very useful at some points. I think that when it comes to powders, and we've seen that in some other, let's say, low volume, but aimed at the organic market and products, is to use simply a protein that is an antibody to a protein from the one of the storage proteins. And usually those small antibody tests can be taken in bigger quantity, which is nice. It will tell you how much of that marker for Baobab will be present.
Okay.
And you can also cheat if you use a nut from a plant in the same family. And I guess Baobab is unique in that sense. The other question I had more was regarding how long does it take for a baobab tree to get to maturity and produce fruit? Because that's the other potential. You can always plant.
If my memory serves me right, it's between 16 and 23 years. Yeah. From yeah, a young hoot to a maturing one that begins to bear fruit. Yeah. But I think, with plant breeding or maybe biotechnology, you could shorten this period. Yeah, but that means you go into domestication now. So grafting, yes. Grafting, yes. 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 Yeah.
How big is the variability? Are there different varieties? Of course, it depends on soil conditions, it depends on temperature, it depends on rainfall, but also how big is the variation in terms of the baobab food? As far as I understand, it exists in quite
A big area.
broad geographic location.
Yeah.
But then also how many varieties exist? Has anybody investigated that? Are there differences also in harvesting methods and so forth? So it's a type of
Okay. Katie is here to assist me on addressing this question. Sorry for throwing you in just like that. But ecologically, I think there are about 4 species of baobab. There are 3, because the Madagascar one, yeah. Yes, yes. So, this- yeah, yeah, yeah. Yes. Yes, yeah, so this is Adansonia dictata, that's fine, yes.
species variation and also different varieties in the species.
Yeah. Yeah, yeah, depending on the environmental gradient, yes. So yeah, it's and the edaphic factors as well. Yeah. Yes, yes. So anyway, okay. No. Yeah, and that's also why it brings this concern about the resource assessment. Because, yeah, these are old trees that are already within the landscape that people are collecting from. Of course, they are very enduring, but again, how long are we going to depend on this until probably we look for a plantation? Or looking at a long gestation period of 16 to 23 years, yeah, this is a resource that brings up a lot of concerns. Yeah, but that should not prevent us from trying. Of course, that's why it's a challenge that we can address. But as it is, I mean, preliminary assessment shows that yes, we can continue with the production rate that we have now because it's still within the niche market. It's not catch up on with the bigger market. And so if you have the niche market, at least what you have now can cater for it. And so then you make use of this brief breathing period, let me put it that way, to now plan how you can upscale this. And that's why we believe, we need to continue the research and not let it go and see how we can address these challenges, particularly with the resource availability going into the future. Yeah. Yes, please. Okay. Okay. I have no knowledge of this, so I'm just putting it down. I'll, okay. I'll ask you more this during the break. So you explain to me so I get at least a general knowledge of what you're heading at. Okay. Yeah. Okay. Okay. Good. Okay, so I'm released. All right.
Okay, thank you very much. Thank you. My name is Itse Jasma. This time I will be presenting my own work. Um, I hope to know more about this topic, oil palm in Indonesia, and all my stakes are my own. I can no longer blame somebody else. Good. The relevance, I will briefly introduce palm oil. Maybe you all know, you know the product, maybe you don't. The global relevance of palm oil. On the left side, you see palm oil fractions and their uses. You can see that palm oil is used in many products, probably in those cookies over there you see. And if we look at all these food products in which or in all these products, we see it's actually in everywhere, and also in many bad products. So I don't know, products which are not very good for your health. So I don't know why the Malaysian Palm Oil Council promotes their product being processed in all these unhealthy products. Anyway, important point is we do need more fats. Parts of the world are still not using enough fats, and the global intake of fats is probably still going to increase. If we look at the percentage of the global vegetable oil productions, we can see that oil palm is the single biggest crop of vegetable oil, source of vegetable oil. Since I thought this was for Latin Americans, and soybean is big there. It's the second one with 28%, and the rest of the world, or the rest of vegetable oils, is 36% basically. But then, when you look at the area covered by the crops, you see that soybean is covering 137 million hectares, oil palm 30, and all other crops almost 200 million hectares. And we see that oil palm is a source of vegetable oils that can be grown in great quantities on a small piece of land. The relevance, yeah, we see here production, the main markets. European Union imports about 10%, and China about 8% as well. Big chunk goes to India, and then the rest of the world, mostly developing countries. Indonesia is here, the producer. This is the total amount of oil palm oil produced, and this is Indonesian production, which is about 50% of the global palm oil production. So palm oil is of great importance to Indonesia and to the world. It's Indonesia's top foreign exchange earner. It provides millions of jobs in Indonesia, and according to the oil palm lobby groups in Indonesia, it's God's gift through the world, through Indonesia. However, we also see big ills associated with palm oil production. The land grabs, the environmental displacement of people. There are many articles about this, maybe you've read them already. Oil palm production is associated with fire events as well. Huge peat fire events in Sumatra and Kalimantan, which make Indonesia as one of the main CO2 emitters globally. Great health issues associated with it as well, and we're talking again about deforestation and environmental destruction. So there are plenty of, there's a big need for improving practices in this sector, reducing the ills and benefiting more from the benefits of palm oil. And the first step is, of course, understanding what's out there. And then we can look at, we look at big data. So of course the first thing we look at is government data. Government data, is not perfect, but it's a good starting position if you're looking. I'm sorry, I was thinking I was talking to students, and of course a good recommendation to start your research is start with the statistical data that's out there. This is anyway, if you want to get an overview, you can see here the increase of palm oil from nearly zero in the end of a few 100,000 hectares to which more than 15 million hectares by 2020. And you can see the different actors. There are many companies involved, but there's also massive amounts of smallholders involved in oil palm production. And here you can see that it's not divided equally. We don't look at the averages, but we look at especially the differences. In which areas do you find different practices? If you look here in Sumatra, you can see more green, meaning that more than 50% of the area is cultivated by smallholders, compared to Kalimantan, where it's 1 to 20%, which means that the vast majority of oil palm cultivated there comes from companies. Any different approaches if you want to tackle the social and the environmental ills. The use of big data. This is an example from Santika, who uses the census data. Of course, census data is a great way of exploring what is out there. How do oil palm monoculture areas compare to subsistence villages which are based on subsistence agriculture? And you can see great differences between those things. It's not about the findings. It's a great article by Santika, which really uses these census data to demonstrate the differences, or to assess how oil palm agriculture helps to alleviate poverty. And she concludes that on economic benefits are huge, but the social ecological costs are considerable. They are quite small, quite low after the research period. Beyond the government data and the census data, there are great remote sensing applications out there. This is the Nusantara map. Nusantara is another word for Indonesia. In which they do all the mapping, in which they have all the satellite imagery. An example of this real-time satellite imagery that monitors deforestation. It also includes data on your companies. It identifies all concessions, all the companies that are out there. These companies are usually part of a larger conglomerate, and you can see which conglomerates are most involved in deforestation, and which one are more responsible companies. And these tools are helping incredibly with monitoring the performance of companies, and thereby making companies accountable for their actions, and exposing companies which are involved in deforestations, which they of course don't want to be associated with. There are 2 links there, great videos on how to use these tools, and the other one is the atlas, the actual atlas, the Nusantara Atlas. My own research, this is my PhD research, was about in search of sustainable and inclusive palm oil production, the role of smallholders in Indonesia. And then, of course, I focused on the smallholders, and the key issues are low access to inputs and low productivity per hectare. The high transaction costs associated with many aspects related to production. Marginalization, we see these big initiatives supporting, making palm oil sustainable. Well, we see that it's especially large companies which can afford such certification schemes, and thereby the smallholders are more and more excluded from the value chain, actually creating the opposite of what we want. Inclusive value chains become exclusive if we focus too much on certification and expensive measures. The key division that I looked in my dissertation was the independent smallholders versus the organized smallholders. Organized smallholders work in groups and are usually associated with the companies, and the independent smallholders usually work on their own and form the majority of smallholders in Indonesia, but they are not directly linked to a company. They are spontaneous producers and often do not receive any support from the government or from companies such as the organized smallholders. They often are able to reach out for support either to companies. They are more frequently able to reach out to companies or the government as they obtain advantages of scale. This is how I used, well, you start out again with what is the big picture. This is the landscape where I did my research, Rokan Hulu, Sumatra. And first things we looked at is deforestation. We tried to identify different landscapes and see whether we see different types of smallholders, independent smallholders. I mean, we talk about millions of farmers, and if we want to look for solutions to improve their livelihoods or reduce the negative effects of their palm oil production, we have to see what kind of solutions do we need to implement, and what different types of solutions do we need to implement, and therefore we need to understand who is out there and what are the different issues. Now, this is my research area. This is one of the research areas. This is a frontier, and it's a frontier based on satellite imagery. We could see the deforestation taking place, when the deforestation took place, and we see a more settled area where deforestation took place a longer time ago. What we then did was map all the oil palm there, and we used company maps for that, concession maps, and we used satellite imagery, Google Earth imagery for that. And we need to combine that with your findings on the ground, this verification on the ground. Are these really the boundaries of plantations, or are these just very big smallholders? And you can immediately see a difference in structure. You can see a real mosaic landscape here in the established agricultural area versus a very condensed landscape of smallholders in monocultures, complete monocultures here in the frontier areas. This is the Google satellite imagery that we used, and I would be happy if we could sit together and find methods to do it more automatically, because what we did is just manually visually inspect all images. What you can see immediately is different planting patterns. Here you can see squares, whilst if you look at good agricultural practices, which is what you want farmers to implement, you should be planting in hexagons, which is better for sunlight absorption. More efficient sunlight absorption and planting densities, etc. This is the established agricultural area. You can see rubber in between, very small plots. This square here is 25 hectares, 500 meters by 500 meters. And the same here, but this is in the frontier area. You can see completely different patterns. These are usually patterns associated with companies, but through verification on the ground, and there we link to the danger of just interpreting satellite imagery randomly. We found out that these are actually people who own 200 hectares, so they're not really a company. They're a bit your missing middle. They're in between your small farmer, and they're in between your 5,000 hectare company, which is a normal 2,000, 3,000 hectare company, which is a normal size for a company, oil palm plantation. Now, below here, you can see some smaller farmers. These blocks are about 10 hectares. That's also very common if you go into a frontier area. Different type of farmers, people from the city who buy a piece of land in a newly established area and start planting oil palms there. It's different than your small farmer with 1 hectare who starts cultivating oil palm in an established area. How did we do that? Well, we used satellite imagery. I already mentioned this. We took a sampling frame. We determined how many hectares we wanted to sample. We did that with ArcGIS, randomly selected squares, and we went to these squares. Well, again, these are companies, and you really have to sort out. Verification on the ground is this a company or is this just a medium-sized farmer? What we did then is, what differences do we see? We looked at what differences do we see, the sustainability and the productivity challenges. So what we did is smallholder mapping. Subsequently, we went in there and we mapped a rapid survey. So when we identified those areas, those blocks, we went in there and went to all fields and found some basic variables on those farmers. And those basic variables included residence, origin, size of planting, and a few those very simple 5 or 10 maximum. I forgot. I'm sorry. How many? A few key variables on which we developed a typology. Subsequently, we had in-depth interviews with these farmers, and we had farm inspections to look at the actual practices in the plots. The typology. Subsequently, a typology was developed based on farm size, primary place of residence. Do farmers reside close to your plantation, or do they reside in the city or outside the province even? The origin of farmers, are we talking about migrants who are moving in and settling the area, or are we talking about the indigenous populations? We looked at soil types. So do we see, we included soil types in there as well. Are they located on peat soils? Do we see differences with farmers on mineral soils? And we looked at land, the legal land status. So are they in the forestry domain, or are they outside the forestry domain? If you're inside the forestry domain, legally speaking, you cannot cultivate oil palm within the forestry domain. So they would have been illegal farmers, and that changes the access you can give them to inputs and knowledge. Cluster analysis, we looked at, well, these are the categories we made. This is what came out. You can see that some categories are, for example, they are, in our sample, they were 7% in the sample, but they occupied, no, they were 17% of the sample, but they occupied only 7% of the areas. So you look at the difference between how much area do they occupy and how important are they in your farmer population? What share do they have in farmer population? The categories that we identified were small local farmers, medium-sized local farmers, large resident, small migrant, medium migrant farmers, small medium peat farmers, and large-scale investors. So the difference between large resident farmers is that they have more than 15 hectares of oil palm, but they live in the nearby area, whilst large-scale investors, they have farms bigger than 15 hectares, but they live in the urban centers. Small local farmers is the people, the indigenous population more, whilst the migrants obviously refer to the people who came into the area. Now, we have all these differences. You can see these variables as price, yields, sources of capital, planting materials, and fruit types. Fruit types refers to planting materials. And you can see that Dura, for example, is 75%. Dura is the low-yielding planting material, whilst Tenera is the high-yielding planting material. And we see big differences between the different farmer types. So if we want to have interventions, it's better to target your farmer types correctly. That was the first part of my dissertation, so focusing on the independent farmers. The second one is about Ophir plantation, which is a collective smallholder plantation with one supra-cooperative, organized farmers, 5 cooperatives, 2,400 smallholders and 4,800 hectares, all smallholders owning 2 hectares of land. GIZ was involved in setting up this plantation back in the 80s, and it was very interesting to look into, because after 25 years or 30 years, they have to replant, and that proved to be a critical event to the collective action. And the institutions that managed that ran this plantation. Why demonstrate this plantation? Why take this case? Because they had extraordinary yields. These are the Ophir farmers with an average yields of above 5 metric tons of CPO, which is a lot more than the nucleus, than the company which is producing next to them. Usually companies produce more than smallholders at national level, for example. You can see that in this graph. So the Ophir case is an example of an extraordinary of success of collective action with farmers. One more, this is the nucleus estate, so the company, and you can see that the smallholders were always producing more. What you can also see here is that at the end, production goes down and there is a need for replanting. And then there is a lot of stress on your production system and your institutions. So we see these massive changes in the organization. We see massive farmers leaving their organizations, but this is not uniform throughout the plantations. This is the plantation I studied, and what we can see here is an example of the big data, which doesn't reflect the realities that you find on the ground. This is from the Nusantara Atlas, which is great, but if you go here, you can see that this is an palm oil company. It's classified as palm oil company, but in fact it is not. I know this place, it was my research field, and you can see that they make quite some errors based on their satellite imagery. So there is a need for verification, and don't trust completely trust the data that you get from big data or satellite imagery. What we did, we used Google satellite imagery again. We mapped this whole replant. We were lucky enough that much data was available via Google Earth. There was 2014 data, there was 2016 data, there was 2018 and 2021 data. Well available, so we could map with 2-year intervals basically how replanting took place. This is an example of a cooperative. We could find each individual plot and identify when they replanted and how they replanted. Here you can see different replanting strategies. You can see here there is poisoning, meaning palms were poisoned, which is it's not good agricultural practices. You leave quite some space for diseases in the field. This one is cleared mechanically, which is a better agricultural practice. These ones are completely poisoned. What I did was we looked at the method of poisoning to identify to what extent they did good agricultural practices. That was one of the aspects. Now here you can see the differences, and it would be great if people could help. We did it manually. There were 2,400 plots, we could do that. But it would be great to do it at a larger scale, of course, and then it becomes impossible to check all these plots manually. It was 10,000 plots being, you said, 4 times 2,400. It was quite a job. So we see the diversity in replanting strategies. We see that in this side of the plantation, people took a different strategy than here. And then, mechanically felled, collectively, whilst here it was mostly poisoned and mostly done individually. And you see some plots where there was no replanting at all. Well, here you have the different phases. If you keep it uniform, it becomes easier to do, and it becomes easier to manage later as well. So that's why it's good to keep all years to all replant at the same time. Now there were all these reasons. We went into the reasons as well, why it went different. there were better natural conditions in one part of the plantation. The cooperatives functioned better. Yeah, there were alternative markets to which people ran, but not all of them ran to it. Some stayed within the cooperative, and that was especially in the best performing cooperative. I will not go into that because that's not about satellite imagery. And the last point I'm working on is the agroforestry, because that was a topic we discussed earlier as well. We already talked about the models earlier this morning. And you know, I have to say that oil palm and agroforestry appears not to be a very good combination if you look at productivity. There are other reasons why farmers still want to do it, and it would be it's still interesting to find out which farmers are still interested in agroforestry and why are they still interested in that. We could look at mosaic landscapes, of course, or not on the field, intercropping, but just having your oil palm plots and your separate other crops. You can have all these trade-offs. Anyway, so thank you very much. That's basically the presentation. Discussion points, yeah, composite data. We used Google Earth imagery. It's often difficult if the dates don't match. Also, of course, there's the problem of, yeah, you can maybe get it all from one date, but then it becomes very expensive. You need to buy it from Airbus or some other provider. And definitely you need to check these things on the ground. Drones, what data can drones provide? I think it would have been great for me to have them to map plantations. Automate analysis. I mean, when you have these images, I'm sure there are computer programs, I don't have them, I don't have access to them, who can just recognize those planting patterns. That would be great. And also, of course, there's recognizing the planting patterns, but also the performance of your oil palms. And it would be great to look at these things with smallholders. Which smallholders are performing well, which ones are not performing well? And can we even see which nutrient deficiencies are there within the plantations of certain farmers? So these are just some points I wanted to mention. Questions, points? Yeah. Yeah. Yeah, I think it depends on the area. I mean, I think intensification in some areas might be a good option, is a good option, because there is a demand for palm oil. I mean, we need to feed our populations. So we need to feed it, and palm oil can produce oil, vegetable oil, from a limited acreage. Now, of course, we need to look at what we don't want is to burn land, to set the peatlands on fire. So we need to find measures to avoid carbon emissions from peatlands. Well, there's multiple things you can do. You can improve your drainage systems in peatlands and your plantations. Oil palm plantations can maybe even help in some respects with that. Maybe in some areas. In other areas, it becomes a matter of land use planning. Exactly, just forbidding oil palm to expand into certain areas. I think that's how to make it more sustainable is, well, maybe improve your traceability as well. And I think there are great initiatives with this big data in monitoring where is it expanding and holding these companies accountable. But yeah, trying to avoid unnecessary expansion and maybe fitting it into mosaic landscapes more instead of having just boom, huge monocultures in which nothing else is there. Yep. Yeah. No, exactly. Those things are happening. I mean, it's already obligatory to have your riparian zones for companies. But how do you do that with smallholders? I mean, if the smallholder is, he cannot allocate 50% of his land to a riparian zone. So then it becomes, and smallholders are more difficult to monitor than those big companies. If you're, yeah, and then you get the whole trade-offs between, yeah, things might be more easy for a big company to implement, and that's what we see. RSPO is especially certifying big companies and not your smallholders, because that is more complicated. Now we might have to invest in finding strategies in which we can certify smallholders better or support. It's not. I mean, certification is just a label, but it's especially about the support to smallholders and yeah, finding ways in which they do not expand, do not need to expand, and support them in growing palm oil efficiently as well. I am not an opponent of intensification per se. Yeah, I don't know the exact percentages, but there are plenty of studies which which state that an oil palm plantation is better than your degraded landscapes. So by having a landscape which has been burned over and over by forest fire, yes, transform it into an oil palm plantation, and then you increase your carbon capture. So so exactly, we should not say stop oil palm, or we are against oil palm per se. I think these are very short-sighted positions. But exactly, where do we do it? Now, that would be a great one. But if you do it in a forest, and you know the government said, oh, it's a secondary forest, it's a degraded forest, we can cut everything. Yeah, then you lose more carbon than that you gain from your palm oil. So exactly, these are the interesting fields to explore. And I think, yeah, we can use big data for that as well. Where are these big areas where we find empty lands? And we still have to go into the discussion afterward. Are they truly empty, or are they still occupied by people? But it's a good starting position. How much carbon is there? Is it suitable? Yeah. Yeah. Yeah, there are. I know in Indonesia there are land swaps. They're trying to do land swaps. So companies again because companies are easy to communicate with, are involved in programs in which they try to arrange land swaps, but I don't know how successful this is. Exactly, going to to degraded areas instead of deforesting their a secondary forest, which can regrow again or maintain its carbon. I still love this field. You're welcome. Anything else? Any other questions? Okay, and then that's it.
Okay, thank you everyone for giving me the opportunity once again. As you know, my name is Shafi, from the Faculty of Life Sciences. Anyways, I understand everybody's really tired and after this long day, but what I want to talk about right now is agroforestry in relations to IT and big data applications. And our objective was to cover resource assessment, certification, and traceability. And trust me, this is not going to be a monotonous presentation. Now you'll see that in a bit, it's going to require more of your participation because we did our homework and now it's time for y'all to do some conference work. Okay? So let's get started. And so, yes, I'd also like to thank all our organizers at our university for making it possible to meet everyone today. So, we've been introduced to agroforestry systems all day today, right? And now you're going to see that why are we really stressing on this topic of agroforestry at all? No? Apart from the definition of it. My area of emphasis would be to apply agroforestry systems in Central Asia. And so just to give you a walk through some of the things that I've looked into so far. What's the relationship between agroforestry and something you probably never heard of, ecosystem services, which would automatically tell you the benefits of agroforestry, no? Not from the initial perspective of what benefits we get from agroforestry, but why we really want to, let's say, promote agroforestry for the future for sustainability concerns. And then we look at existing IT and big data applications, is when I, give you a round of applause for all of the efforts and commitment you've put throughout the years to bring us to this situation. However, just to highlight that your work as an IT specialist or an informatics engineer is not over, right? There's a land of possibilities, and we need your help. Now we can't do it alone without you. And so I'm going to cover the ongoing constraints and the areas of potential improvement. Okay, so some of us are here probably for an idea. What can I do? What can I sell off? And so I went through a whole bunch of literature and existing problems that farmers really face at the moment, and they need information for this. And you have your existing technologies. We talk about that. Maybe when I talk about my problem, you can combine the resources you have to find a solution to that. Because at the day end, I'm looking for the ones that are most, resource efficient, most cost efficient, solutions. So I'll talk about the problems, and then maybe you can propose, hey, this can be done quite easily if I do this, this, and that, which we basically couldn't find in, empirical literature these days. If I'm going too fast, slow me down. If I'm going too slow, speed me up. Okay, great. So we basically know agroforestry systems has a combination of supposed trees, crops, and animals, right? So we talked about the silvopastoral system a while ago. And and from the definition of agroforestry systems, it's not just a combination of that. You see that it says land management system and technologies where woody perennials are deliberately used with agricultural crops, blah, 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 with animals in some form of spatial arrangement. Well, you see the word technology is also included there, right? Which means it also includes my, IT experts and students who are, looking to thrive in this, in their careers in this area. So technology relates to innovation or improvement to either modify an existing system or practice or develop a new one. Typically, we don't get radical innovations every day. Doesn't happen. It's once in a while. But I'm requesting that when I talk about my ongoing constraints and problems, you tell me something that we can use by modifying the system to find a solution to the problem. Okay? Hope everyone's following me so far. Agroforestry systems, although we're talking about implementing agroforestry systems, and we're saying, oh, it's always positive. Why isn't everybody doing it? Right? Why are we here today trying to encourage everyone to apply agroforestry systems or adopt? Because it's not always successful. Because there are species combinations that cause issues, right? When you talked about how do I know which species would give me the optimal output? We need information towards that. Management practices. Different areas in the world have different management practices. We need information on that, and that's why sometimes they don't succeed. And then there's a lack of people's motivation and understanding. There's disincentives for engaging into agroforestry. However, from an overall perspective, we see that agroforestry systems, they encourage productivity, sustainability, and adaptability, which means it's something we can look into. And so in a nutshell, these agroforestry systems, they provide multiple products or benefits in the same piece of land. That's the motivation we get. And so what is the aim for this topic? Whatever we're analyzing, we're going to analyze IT applications and big data applications that have already taken place. And we want to improve resource assessment, certification, and traceability. We're not going to go into the aspects of what is resource assessment or the stuff that you can probably Google, right, for definitions, due to the lack of time. We need to come up with incentive policies to internalize environmental services. And you'll see that with the agroforestry system, you're not only given tangible benefits, right? You also have environmental or non-market goods and services. And you'll find that in a bit. We also need to enhance our understanding of agroforestry on the environmental benefits it provides, and that's why we're here today. Some of us even never probably heard about agroforestry at all, and you're hearing it for the first time. And we need to support sustainable land use management. Okay? Great. One of the reasons why we focus on agroforestry systems is that agroforestry systems have a higher potential to achieve, the production of ecosystem services in comparison to most other agricultural options. No? This is well cited in many papers. So my focus is in agroforestry in Central Asia, where there's very few research going on. No? And so what I've done is that I went through different literatures on Central Asian countries. And so you have, we're primarily focusing on in Kyrgyzstan, but I have other countries within Central Asia that we'd like to learn more about the agroforestry practices there. Apart from that, I take a whole bunch of information on bordering countries who have adopted agroforestry, who were successful, who are unsuccessful, and acquiring all this information from the data, from the empirical literature, I find that agroforestry systems contributes to the maximum production of ecosystem services. And so you might say, what do you mean by ecosystem services, and why the heck should I care? Right? The reason why you should care is because typically when you think about outputs, you're just looking at the provisioning services, which means from the barrow tree, the chestnuts that you get, it's a form of food. It provides fiber, suppose. Who knows? Other services that you get from a system, from agroforestry, is that suppose there's genetic resources or biochemicals and medicines. All of the things we talked about in the past were related to provisioning services. However, there's also regulating services. When you have an agroforestry system, it regulates your air quality, right? The air that you breathe. Free oxygen, basically pure. It regulates your climate, right? There's water regulation, right? Because the rainwater gets filtered into the environment and stuff. It protects you from supposed diseases and erosion from occurring, right? It regulates pests and provides pollination. So you automatically understand the advantages of it. And now you might think that, hey, what in the world? Okay, it provides these services, but I'm not only benefiting from it, everybody is. That's the biggest problem. And you also have cultural services, right? Sometimes you have spiritual or religious values, cultural diversity. Sometimes you just like to look at it because it's beautiful, a forest. And then there's supporting services, suppose photosynthesis, soil formation, and all these other benefits. No? Without me sounding like blah, 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 consider the fact that there's provisioning services and there's so many other benefits that we reap from an agroforestry system. But the problem is, I'm very straight up, not all ecosystem services provided by agroforestry have a market price, which means if I'm a farmer who practices agroforestry, I'm only going to be paid for that output that I give you. The rest of the clean air, climate regulation, and all that good stuff that you also benefit from, I don't get paid for it. And therefore, there's a need for us to find the value of those services. And that's why my second objective was that we need to internalize the payment of these environmental services. Or so far is everybody on the same page? Cool. So, agroforestry benefits, they provide employment opportunities, they give additional family income, they provide nutritional benefits. Now you see there's for the benefits for consumers and producers is what I'm trying to get to. Better standards of living, a variety of agroforestry products. You can get access to better information, more products, more people involved. And it ameliorates environmental benefits, which means the critical ecosystem services, it gets enhanced. Because these ecosystem services that I talked about, climate regulation, for example, or air quality, this is degrading on an overall perspective globally. So we need to take an initiative to at least maintain or sustain the situation we're in. And when it comes to sustainability, also have an endogenous growth system that rejuvenates these ecosystem service provisions. And so another thing is that it reduces, with agroforestry, we can reduce domestic energy expenditure compared to coal or LPG, right? So it's also being less dependent on imports from throughout the world. Sometimes less trade is okay. Okay. So, from an economic perspective, if we're trying to do new research, these are the different areas, geospatial variations that I found out through different literatures that I went through. And I jotted down areas of information that we can acquire. Which means if you ask me as an IT specialist or an analytics specialist, what kind of information do you need? I tell you, these are some of the informations we typically see that varies from one country or region to another, right? As you can see, we need more information on population characteristics, the climate itself, site conditions, growing season and length, suppose the altitude or the rainfall, things that you probably already know. Right? Okay. But we also need more information on harvest, transaction, and processing costs and stuff like that. Things, if we took time, we could probably get information too. Which means this is a lack for us, not just in agroforestry, in all sectors of agriculture, that whether or not, the things that we could implement, we don't do it, even though we have the resources for it. So where's the problem? So we have existing agroforestry, IT, and big data applications. This is an award, and this is also, a chance for you to share insight into. First of all, we need information, right? Who benefits from your information that you provide today? There's different stakeholders. What you can say today is that you provide benefits for the farmer, us researchers, extension workers, different private enterprises, and policymakers. Okay, so these are the different stakeholders that benefit from your applications. And how is efficiency achieved, right? Sometimes we say we want to be more efficient. All we think about is costs. No. Sometimes we need to be more efficient in terms of data collection, analysis, reporting, and creating a communication between these stakeholders. That's what is going to get us more into, to become more efficient. It's not just about reducing costs more and more, chopping here and there. No? We're done probably with process innovations, almost, unless there's more, technological improvements. And so, IT specialists and big data application developers and stuff like that, they've done a great job so far, right? We've talked about GIS. Everybody knows the type of information we acquire from it. Through that, we can detect, suppose, land patterns or identify optimal agroforestry plots. Possible. We have sensor-based data. Why am I saying this? Is because I'm trying to remind you of all the resources you utilize so far. You have sensor-based data, which means we can find out how to use water and fertilizer most efficiently, right? We have precision agriculture, which means with precision agriculture, we can get better understanding of, suppose, crop yield and stuff like that, and how it grows over time. We have, suppose, the decision support systems, which means we can have different agroforestry adopters based on the conditions that they have, and we can get consultation services for that. We have these things. A smart irrigation system, right? Water is a depletable, is a scarce resource nowadays, right? And so, due to the different types of pollution, therefore we can have irrigation access to become more optimal. Great. Apart from the rest of the stuff that you can see, is that all of the things are self-explanatory. We understand what digital marketing is, or climate modeling and forecasting. And so, I thought that it's important that we analyze what's still missing now, based on what we have. First of all, we need problems that I've come up in different literatures, that there's a lack of knowledge about the benefits of agroforestry. No? So this is something that probably takes place in the long term, creating knowledge or awareness of agroforestry. The second thing that farmers have is the lack of investment incentives. right? When you invest in agroforestry, the reason why it's not so widely adopted is because it requires a long-term investment, an initial investment that is high, and returns that come, I don't know, after 3 years into the future. So a smallholder farmer who's probably thinking about adopting such a practice says, no, I'm going to go for an alternative where I can gain money every season. And so we need to create incentives for that, investment incentives. We need to create communication between academics and research organizations. So when I said about investment incentives, what can you do as an IT specialist? You can connect. Like I said, the idea was to connect the farmer to to connect the different stakeholders. We need to connect the farmer to, suppose, financial services that they can get. Sometimes you have farmers saying, okay, do you know what the optimal level of agroforestry, like the combination of products would be if you had to adopt agroforestry? And they scratch their head and say, I don't know. Which means they need to have access to advisory services. You know, what I'm trying to get is that we can have agroforestry practiced throughout, different regions in the world. However, we need a documentation of this so anyone can access that type of information. These farmers, all they say is, I don't know. And there's something that we can do about that, and we still haven't. Will you find this in literature? Maybe not, because you have to ponder over these thoughts a bit before it comes out. Yeah. And and there's also an absence of, suppose, specialized skills, of, suppose, in fruit growing or tree grafting, like some of my colleagues said today. So there's a lack of training. If I'm an entrepreneur and I want to, invest in agroforestry, I might want to understand if labor is mobile, suppose in Kyrgyzstan. Do I have those individuals that know about this? Can I hire the most efficient laborers? This is something that you can probably apply as a database to give us information or profiling of individuals who are specialized in this area. This is something that you can do. The intuition from this is that you should be happy when you apply this. These are really, really poor families. And when you can assist them, they have the abilities to send their children to school. And I think that's really great, even when we're gone. That's just an example. See, I give motivation as I make you listen. Okay. Another thing is about the information on equipment to process tree products, agroforestry products. They don't have any information regarding to that. You have to have delegates going all the way from Germany to somewhere in Central Asia to tell them that, hey, there are state-of-the-art technologies. They should at least have information to this. Okay. And I said about the lack of financing establishments which ensure funds, which means I would like, that there should be a database that unites farmers to financial institutions where they can acquire this help. For example, maybe they can acquire the funding for 3 years. The initial 3 years when they generate no income, according to the plan, they can receive some financing for that. This is, I think, something that you guys can do, right? I probably couldn't, but I know the problem. Okay. Information and support for improving agricultural production and adopting new varieties and practices. We should have something more dynamic where, the farmers can identify, okay, what's going on, what's new in agroforestry in different countries around the world. And they can acquire this information. They can reach out to those farmers if needed, and they can get compensated for that as well, for this information. That's another source of income. Okay, and for many of these products that we talked about agroforestry in general today, and my team, and I also went specific into products. You also saw that we have no information of current market prices for certain products. Can we have that? Yes. And so sometimes they can do their own evaluation. So different people around the world have different agroforestry practices. We can see whether or not, who's more productive and what's the best practice going on around the world? And what is the best species combination? So what I'm saying is that getting all this information that we already have easily with the resources you have, I don't know, could be your drones, right? Who knows? Or your, sensors that you utilize. Or maybe through GIS, or combining each of these things together. And you end up with something that, that is there for better dissemination of knowledge. Not something that, we could be general about, something that's really practical. And something you don't have to go home and do homework about, but I gave you the problem to use the same resources you have already. And another problem that we face is we need survey data. I know it's a very ugly thing, but survey data provides us information on differences and opinions, right? We run so many statistical tests you probably couldn't tell. Not on the same supposed demographic information, maybe their preferences. How does a farmer really think? What are the problems that they face on a day-to-day basis? We don't know. Can we suppose document this change over time? So as an agroforestry farmer, how does their perceptions change over time? How do the minds of suppose consumers change over time? We can do this with suppose existing technology so far. And then there's a lack of technological knowledge and expertise of IT. So the farmers, like I told you, they don't have that type of knowledge. They don't know what to do. They don't have the technical skills to use this. So can you make it more user-friendly than you are based on what you've made? Can we have, suppose, something that's still not there, right? Organizing meetings and training programs for different farmers, right? Digitally. Maybe they don't have to travel now anymore halfway across the world for this information. All you need is someone who's a good translator, right, to arrange this meeting. It's possible. And then, different agroforestry management practices throughout the world. And individuals can, get registered into these platforms where you have certification, right? Certified agroforesters who can only share this information with themselves. And they benefit from this, right? Apart from all the things that hits to the market, right? Who uses this product, right? So we don't have to actually go behind using other indirect valuation methods. No? We are more sure of that. I know that it costs money to do that. And and the reason why we don't, we haven't come up with solutions for this is that because it's expensive. But I want you to identify the ones that are least expensive and what you could do at the moment to overcome these problems. Yeah, suppose the tax situation, monitoring that. No problem, I'm done. And so these are ways that I say to improve resource assessment, certification, and traceability. And so on your side is that you have your resources, you understand the problems. Can you propose something maybe you could solve right now? Please. Sir. Oh, sir. But that's the thing, right? These individuals also, these farmers, they also don't have the technical skills to suppose surf the web like we do. Heck, they don't even, sometimes they probably don't even have 3 meals a day. That's why they don't adopt it. So I understand your perspective, this from the social media perspective, but that's the thing. Now, first thing is money, because they can't survive. Hmm. True. Even the beggar has a smartphone, huh? When his time's up. Okay. Thank you. Anything else? Yes. Thank you. Of course. I do. I do. Thank you so much. But we had our hand here. We had a hand here. Thank you. Any other questions? Thank you. Okay.
Hello, how are you? Let's see. 1, 2, 3. Yes. Well, hello. It's good to have you half asleep now. Just kidding. Nom, nom. Okay. This is my name. I'm the Linux guy again. My name is Carlos Martinez from the Faculty of Engineering and Architecture of the Catholic University of El Salvador. We have already had an introduction where El Salvador is, the tiniest country in Latin America, I guess. And let's start over the current situation directly. How is the situation of environment and farming production in El Salvador? First of all, as you might know, it is the third world. There is so much poverty. It is very well known. and farmers have poor access to information. That's why I felt identified with the man who was there, but he's not anymore, who was saying that in Latin America, everyone has at least one cell phone with internet, not just a cell phone. The cell phone plus internet plus satellite antenna plus computer. How is that possible? Well, that's Latin America. That is possible in there. So there are priorities. First of all, the iPhone, and then some other things like secondary things like school, food, medicine. That's Latin America. So even though they have that media, they have poor access to real information. They use it just for fun, for watching videos, for chatting with an affair or something. But they don't take it seriously. They are not prepared for that, and they are not intended to do so. And there are commercialization opportunities very limited. If, for example, I am a cattle producer, I am producing milk, I cannot use my cell phone to connect to a restaurant in order to sell them my milk because I'm busy using Facebook. Well, now that Facebook has the marketplace, something has improved a lot, but not much. And farmers depend on intermediate dealers, people who get the products and resell, taking the biggest share. There is therefore lack of trust, not surprisingly, and no access to national market opportunities. They just sell to the tricky business guy who lives outdoor. And no data collection for it. That is important. There is no data collection. Government doesn't know anything about it. No university knows nothing about how that thing works. And there is a solution. We have proposed a solution. El Salvador has a new Bitcoin law to take advantage of. What is that law? The banks are forced to exchange Bitcoin per dollars without any commission. So it's a legal tender for us. So if you have a lot of Bitcoin, you can travel to El Salvador, exchange it there by dollars, and come here and exchange it for euros, of course. But you will not be able, you will not be charged by any bank. It is illegal. So why shouldn't we do business with Bitcoin and just exchange the Bitcoins in a bank? It is allowed by the law. So there is where the smart contracts are important. We could develop applications that could be based on web platforms to show products, offers, demands from restaurants, from enterprises, from householders, etc. And start making the farmers make business directly and create automatic payments. Like if I deliver the milk every day, so just with an account with the smart contract application, I will be receiving my Bitcoins. If it's like an Uber, people get paid automatically. It was already invented, well, something like that. But the proposal was to develop a framework using blockchain. Why blockchain again? Because information can be distributed. It can be public administrated, and we will be having data redundancy, and government could have some control, not control over the business, but control over the information at a certain point. There are some issues that has to be taken in care before, because some people could say, hey, where is my privacy? Well, I'm not saying that we are going to tell how much a farmer is making, but we could share some statistics, something impersonal. And that is, well, of course, very important for people who are experts in business stuff, Well, information could be available immediately. Like, for example, a restaurant says, hey, I need 1,000 pineapples. Then a farmer 50 kilometers away could say, I have them, but nobody wants them. Okay, bring them there. And no intermediate businessmen who are the ones who take the biggest part of everything. And so, as I was speaking before to someone, he told me that the stuff about Bitcoin and blockchain is not pretty clear. Too many people talk about blockchain, how it works, but people not always know how it exactly works. So I will make a small demonstration just for you to understand how it works. So this is an application I developed just for an example. This is a very small example in which I launch servers of blockchain, real servers, which are inside of my computer, of course. But they, in the background, they actually behave like ones. And to start a server, I need an IP address. The most typical IP address is this one, the loopback. Let's see. No, it is already there. Server location, let's say this is El Salvador. Okay, I will create a new server, and this is a server application. It doesn't seem like, but in the background, it has all the socket communication system in order to transmit blocks encrypted. And I am going to create another server. For that, I need a different IP, like the real servers in the internet. Let me cheat a little bit. I will use the IP I was provided with the internet of this place. Thank you. Oops, didn't work, the copy and paste, sorry. Okay, that is going to be and let's see, this is Germany. Okay, a new server. What I have here is 2 copies of one server, but they are actually working independently. Let's minimize this. And I am going to create 2 people here. Like, for example, I can see any card. Your card. Excuse me. Oops, insert. Thank you. So insert is going to join the server of El Salvador, and he will be having 100 euros. And here he has his new wallet. And the thing is that he registered in El Salvador, but the other server in Germany received a copy through the internal mechanisms. This is not fake Windows. This is the real socket communication protocol working in there. This is the easy part because you are seeing just the graphical user interface that has to be friendly. Now, let's set another person. Let's set name? Sandra. Okay. Now, Sandra, she's going to be having 500. And she's going to better. She's going to be living in Germany, and now she has her wallet. She registered herself in Germany, but the other server receives a copy of the chain. And let's make a transaction. Insert is going to send money to Sandra. And he is going to give her $99. I'm sorry. And which server is she going to use? It doesn't matter. All the servers have the copy of the entire chain, and she could use both. Which one is any one of them which is closer, faster, whatever. Let's say that insert is going to be using Germany server. Send. Now insert has $1 and Sandra has, well, the rest. Is it okay? You kind of agree, but you don't want it in virtual life. You want it in real life. So the balances. Now the summary. This is the summary. First of all, we have the first block saying that the wallet is giving $100 to insert, $500 to Sandra, and now insert has to give $99 or euros. She accepts dollars as well. There it is. That is the server of El Salvador, and Germany has actually the same information copied. That's it. I mean, these are real independent servers, not just fake windows. And this is like how it should work, just for sending money. So going back to the presentation, we could do the same with contracts. So a farmer could use a mobile application. All of them have at least one mobile device. Then a web application, and he could get information. He could provide, I'm sorry, information about a contract. I have I don't know how many gallons of milk. I want to sell them weekly, and someone, a customer, could accept that contract I am offering and set a price. It's like a little small stock market, like very small. Something like that works in Korea, but the government has a lot of influence. This is without the influence of the government. And what could the framework do? Some easy stuff. A smart blockchain, no, a smart contract blockchain should be developed and has to do all of this. See the smart contract offers, manage the acceptances, terms and conditions, reserve funds, like for entrusting trustability. Let's say I have 1,000 goats to sell, who knows, and I'm going to send them to another country, but I need to increase trustability. So the wallet AAP means abstract programming interface, could let's see what it is, control payment, secure money transfer, could validate the funds and could fix the funds and put them in wait, like reserved, until the transaction is complete. So that is it for entrusting the business. And what else can be done? Here it is, reserve funds. Then the payments could be made automatically. There should be control of membership, and the interoperation with any cryptocurrency could be Ethereum, but we have the law of Bitcoin, so it could be taken advantage of. And what is this? This is the AAP, who's going to work with the actual and real blockchain of cryptocurrency for authenticating the users in a wallet, manage securement, transfer money, validate the funds, control the transaction log and the payments. So at the end, this is working, this is designed to work with two frameworks. The one for the commercialization and the other one for making use of the cryptocurrency. This is pretty good and pretty effective. Just wait. Actually, China has prohibited these kind of things, but not because it is too bad. They have prohibited because it is too good and people were not paying taxes. It was, yeah, yes. There is no taxation considered at this time here. It is possible, but our laws don't get involved with that. So if there is no law, it is allowed. That is the main principle. We have no laws to regulate this, so we are allowed. It is legal, since there is no prohibition. And there, some other people start saying, "No, Bitcoin is not that good." Well, it is good if you change the money of the Bitcoin automatically into dollars, which is legal. to do it electronically. An API like this, an abstract information and programming interface, could take the bitcoins, and if you don't want to be susceptible with the variation on the prices, it could be translated into dollars into your bank account automatically, and our government approves that as a law. That is the thing. So, and to finalize, this is kind of complex, but not that much. Many members could participate of a contract. They are going to be related with the detail of the contract, the balance. For example, one member could be offering something for the contract, and the other member could be obtaining the goods from the contract. Oops. So this could be the offering guy, and this could be the purchasing guy. A contract will take place with the detail and the balance, and some wallet accounts are going to be interoperating with the decrease and increase funds in the wallets. The one who pays will have a decrease, the one who sells will have an increase. That is pretty simple. I don't want to make it so complicated. So conclusions. Oh, that's in Spanish. Sorry, I forgot. But the conclusions, conclusions are, well, most of you speak Spanish. So technology at the service of fighting poverty and instant payment methods, negotiations could be taking place even in untrustable circumstances. There could be registry for logs of data, traceability of data, even data for big business analysis, and well, private and public sectors could be taking advantage of it. And that's it. That is my thank you for your attention. Here it is my email in case you want to make any further questions. And if you have questions now, I'm more than willing to hear questions, comments, controversies, complaints. Oh, yes. We will be forced to launch a pilot effort in order to train. It's more like a thing of creating culture, because they already have the technology. They have electricity, they have devices, good devices, better than mine, but they have to know how to use it. And then, yes, we have to educate our people. That's one of the biggest challenges, which is bigger than this one, bigger than the developing of the technology. That is for sure. Thank you. Someone else? Oh, tell me. Okay. Yeah. We have a law that allows us to exchange dollars per Bitcoin without any payment. There you go. There is no taxation. Law says that the government is not going to get involved in those transactions. Okay. Okay. There is a platform developed by a consultant agency. It was required by the government. It is called Chivo Wallet, but you are not forced to do that. Democratic cryptocurrencies allow you to develop your own wallet if you know how to do so. Ethereum has its own AAP, which is a framework to develop your own wallets, so you can do it. You can add the programming sentences to a website in order to create your own interfaces of programming. You just need your account, your token, your password, your personal information in there in order to communicate. Like the email, you don't have the email application on your computer, but you have access. So there are kind of many ways, and you are not forced to use one standard platform from the government. The law is to restrict the banks from taking profit of it, not to restrict the people by now. Yes? Yes. Yes, I am aware that is complicated. One of the things that could the API do is to store a ranking for sellers and customers. So you have to take care of your reputation. That's for the very number one. That is perhaps not that strong regulated method. That's number one. Number two, a part of the money could be secured in an account to be compensating any kind of problems you could have. That is one another thing. And the other thing is that the information could be available for the government if there is a legal issue. That is something very important. This could be opened by legal requirement, so a judge could clearly and trustfully see all the traces of the information. So it is going to be easy to see who is not accomplishing with the contract, because you will be having the logs, and the government is going to see all the reports, like if there were phone call reports at a certain point. But in that case, we will be needing from legal instances, because we don't have the power to control the legal side. Yeah, thank you. Someone else? Someone else? No? Well, thank you very much for your attention. And she wants her 99 euros. She wants her 99